All right. So this is kind of interesting for Dawn and I. We did this, about 10 days ago in Victoria.
Yeah, in Victoria. And that one, I was driving, and Dale was the
passenger.
Was the color guy. So now we've switched it. So I really have no idea what's going to happen, but that's the way we like to do it.
And the other fun thing is that we've each gone and done all our presentations by ourselves for 5 days.
That's right.
So you're in for a real treat as you see the streams cross and be brought back together today. So what are some of our goals for today? Well, it looks like we used to dress up, but we're not dressing up today.
That's right. But the number 1 goal still is to have fun, right?
Yes, even if we don't dress up.
That's right. An audience that's awake is much better than an audience that's sleeping. So.
Yes. So we're going to have some fun. We're going to learn some things. We're going to hopefully learn from you. We got lots of safe staff down here today. Folks on the live stream, please pepper that back table there is just standing by waiting to answer your questions. So keep them on the ropes. Ask them. One year we had somebody ask which came first, the chicken or the egg, and we actually gave them back an answer. So,
oh, wow.
So and no question is off limits for the group back there. So keep them busy. If you are here, you're going to get some great food as well.
That's right.
The people on the live stream, it's up to you what you're going to do for food.
That's right. And we save all the money for lunch. So so the breakfast was, was okay, but lunch is where it's at.
I think Mark is going to show a little bit of a video, do you, at the beginning?
If we can call it.
Right. So what you'll see is that what you'll see is that we took some of the money from the video budget and put it towards lunch.
Yeah, we completely blew it on the splash screens. That's what I told people.
So we got also, speaking of blowing money, we have our fancy welcome package here.
And this zipster is a good story here. It was supposed to be a third the size.
Yes.
It was supposed to be a bobblehead. So if you notice on the bottom, it was made by the bobblehead company. So we made the assumption that it would be a bobblehead.
It does not have a bobblehead.
It does not have a bobblehead.
You can make it into one, but
That's
then
right.
it won't...
The arms are supposed to move, but they move exactly once. Okay. And
it's a choking hazard, Don.
Yeah, and if you do get this in your mouth, you will choke. Okay.
So
it's actually a great bath fizzer. You drop this in your bathtub and it just fizzes away like crazy. So
we should hold this up so that the live stream for the folks at home, can you zoom in on that?
Yeah.
It's like 3D, okay, the 3D zipster coming right out.
I think it would look great in a Royal Dalton cabinet, actually.
Yeah. We've actually had customers suggest they take home 2 and then bore these out and have a salt and pepper shaker.
Ah, that's good.
There's all kinds of uses. The one thing we do know is that at the end of today, there'll be none left on any of these tables because we're going to be begging you to take them.
That's right.
If you're here in Vancouver, you have to take at least one home. So that's the thing on the zipster. All right. We've already talked about the questions. Please keep those guys on the ropes back there.
Yeah.
So I think we're good on this. And if you're online, there is a way to ask questions in there as well. There's an online question panel thing in there, and here's how.
Oh, wow.
Did you know that slide was there?
I did not know. This is just a Vancouver-only slide.
That's right. So click on the word bubble icon,
go.
not the word bubble.
Right, that's right.
Just the bubble icon.
Click on the bubble icon.
There is no word bubble anywhere.
That's
so, okay, and then they'll answer your questions.
Yeah, and if you're here, of course, at lunch and during the breaks, we got a lot of safe staff here, so make use of us.
Yeah. I think that's the same slide as the previous one, really.
That's right, yeah.
Okay. So with that, I think Dawn and I are going to hand it over to our good friend Mark Stokes and fellow traveler. Mark led the central team.
That's right. I led the East Coast team. Well, actually, Craig led the East Coast team. We always go with the best-looking guy leading each team. And
so let Mark figure out who's led his.
So I guess it would have been Steve would have led the...
Yes, Steve led ours.
That's right.
Thanks, Steve, if you're watching in.
That's
right. So Mark, we'll hand it over to you to introduce us to FME Desktop.
Yes, thank you very much. We called ourselves the MAD team, actually. Mark, Aaron, and Drew, not the central team. So we thought we'd kick off the day with a quick overview of FME Desktop, and for those of you that haven't seen FME before, it'll be a little bit of an introduction, and for those of you that are FME users, we'll just have a quick look at some of the new functionality that we've been adding. But remember, today, you do need to pay attention, stay awake. We will be having a quiz at the end of the day, so, and there are numerous prizes, including the spork collections that you can keep on accumulating and so on. And you also do need to remember that the zipster, when you put things up like your old Corgi toys and Matchbox toys, they're much more valuable if you keep them in the box. When you sell them on eBay, they become... And you never know, they might become collector's item. Next year, the theme might carry on, and so we might be putting out jetpacks and zipster guns to make the whole collection increase. So these might become precious items, I suppose. here's the sound going. That's as far as the budget goes for the movie. And if you go to the Esri user conference, obviously they have a bigger budget for these kind of things than we do. So the FME capabilities, obviously our role in life is to help you translate and transform your data, and that's something we're working on all the time. We started in the CAD and GIS world, added spatial databases, and we've kept on adding other spatial and non-spatial contexts to the kind of work that we can do. And more recently, focusing on cloud kind of formats, and so we'll be talking a lot about that throughout the day, and also non-spatial arena. So many people have been using FME for non-spatial tasks, and that seems to be a growing area. And so we're putting in some focus there on both the formats that we work with and the transformation tools that we're adding to FME all the time. We cracked the 300 mark on the formats this year for the FME release. The release that we're working with in our demonstrations today is the FME 2013 release, Service Pack 1. So normally we have a release every January, and then this year we kind of continued that release schedule, and we did put out a release in January and just more recently put out a service pack which has quite a few tools around the non-spatial arena, and hopefully we'll get time today to illustrate some of those. We're always working hard with our partners. Our role in life is to get these different groups talking nicely to each other, maybe in a literal sense as well. We're integrated into some of these platforms quite closely. If you're an Esri user, we're in there as the Esri interoperability extension, and we're always working on improving that and keeping it up to date with the latest release of Esri. This year we did quite a lot of work with other partners. Socrata added a reader and writer for that, and the Teradata folks. We've had a reader and writer in FME for quite a long time for Teradata, and this year we've been improving on that using one of their newer APIs. So working with partners is always an important thing for us. We focused on the two core products at SAFE, FME Desktop and FME Server. So just in this little session here, I'm just going to be giving a quick overview of FME Desktop. And later on this afternoon, Stuart, who's back there, will be giving an overview of FME Server, as well as throughout the day some uses of those from some of our users, and a fun trek as well, which will come after the break. Of course, our focus in the FME Desktop is the FME Workbench application, where you lay down the workflows that we can use. And you'll see throughout several of the presentations today the idea of creating repeatable workflows. We've been doing quite a lot of work underneath the covers in Workbench. We've had to move to a new technology called Qt for the interfacing, and so that's something as a software vendor you just have to do and swallow. It's a long road to move the underlying technology, and for a long time the users don't see the benefits of that. But that will start to emerge in future releases. One of the spin-offs hopefully will be support for FME on a Mac or Linux. And the other thing that actually I find really interesting is that we're going to be able to improve on the nature of the dialogues that we have in our transformation tools and have more intelligent dialogues. So that's been something that we've been doing a lot of work in. You probably haven't seen too much benefit, but as we move forward, you'll see the fruits of all that hard work by the development team. So although we cracked the 300 mark on the formats this year, we still see that transformation is a major part of FME, and shifting the data model in the different ways when you move between different platforms or different formats and different spatial contexts. And so we're always putting in quite a lot of effort into the transformation tools in FME. And broadly, what we have is transformation tools around attribute transformations, geometric transformations, and then raster transformations as well. My light pen's given up the ghost here. The bottom illustration there shows one of the interesting things about FME, and that's merging data from different spatial contexts. So in that case, taking some point cloud data, maybe making a DEM out of that, overlaying a raster on that point cloud, and producing some sort of a 3D model, maybe a 3D PDF that you can hand out to people sort of so that they can see it more easily. And that's always an interesting part of FME. So we have the sort of traditional data translation and transformation tools, but you can also use FME sort of for bringing together data from very different contexts and merging them in interesting ways and producing hopefully interesting results. And we're always adding new transformation tools to FME. This year was no exception, so there was a big list of transformation tools, and also trying to bring together and merge transformers. We've done some work around this non-spatial context, so you're going to see today some work that we've been doing a lot on testing if-then-else kind of workflows and setting conditional values. So there's been quite a lot of improvements there. Map text labeler is a transformer that we added this year, which is technology put together by the map text folks, and we've integrated that into FME, and that allows you to put together more cartographic quality text in FME, and we'll be illustrating that as well. And around point cloud and some of the other areas that we've been working on, point cloud filter, point cloud expression evaluator, which sort of allows you to do interesting manipulations on the point cloud data in the same way that the raster expression evaluator is a very efficient way of doing expressions on raster data sets. We've also been around the sort of area of cloud-based data sets, also looking at sensor data, and so a couple of the transformers that were added, TCP/IP, sender and receiver, allow you to build workflows that monitor continuous sensor kind of information, water level sensors, vehicle sensors and whatnot. So those are transformers and an area that we've been pushing on this release. Of course, the actual core area of FME is around the data model transformation, and then underneath that is always our coordinate system transformations. Those are a fundamental part of FME. And this year we upgraded our coordinate projection engine, which is based on CSMAP to CSMAP 13. And that gives you a bit more, well, actually a lot more flexibility in the way that we handle datums in coordinate projections, and separates the datum from the coordinate projection a little bit. And so you have a lot more flexibility. So if your coordinate projections, if you're really kind of keen on that area, that's something that you should explore as the new tools in CSMAP, in the CSMAP 13 upgrade. So let's have a quick look at the FME 2013 and see what we've got there. And one of these tools here, there we go, the data inspector, is something that we've been working on a long time. So the two core applications that are in the FME desktop are the visualization tool and the Workbench. And for quite a long time, we've been working on a replacement for the existing universal viewer in FME, and we call that the data inspector. And the motivation for that is to add 3D visualization to the inspection tool, because we've been increasing the amount of support for BIM and 3D formats. That's taken us a little bit longer than we would have hoped, and so we now think that the data inspector is ready for prime time. So this is the data inspector, and one of the great things that we've just recently added to that inspector, if you're currently an FME user, is a table viewer to the inspector. And that allows you to more easily look at non-spatial data, which is a big step forward to the old visualization tool. Now, if you're not an FME user, you're probably sitting there thinking, well, what's the big deal? That's a big table viewer. And it has taken us a long time to get around to putting this in. But for those of you that are FME users and you've been using the visualization tool, certainly recommend giving the data inspector a try and using the table viewer. And in FME Workbench, where I've got one up here somewhere. Here we go. If you want to use that visualization tool or the data inspector, then you can go to the FME options, and then under the Workbench options, you can, not too much real estate on the screen here, you can see the inspection application, and you can switch the default from the universal viewer to the data inspector and start to play around with that. So I certainly encourage anybody who's been able to upgrade to Service Pack 1 to get going with the data inspector. So this is the sample data that we're going to use for a quick demo in Workbench. It's based on some electronic navigation charts around that we've loaded into a SQL Server database from S57 data. And with that, on the sort of theme of sensors, is I've loaded up some AIS data, which is automated identification systems that larger ships are supposed to ping off. So it's basically an international standard for GPS signals from ships as they move around. And so what we're going to try and do is pick up a few of these vessels, make a vessel track, and join it to a database, just to illustrate some of the functionality that we've got in FME Desktop and FME Workbench. So as always in Workbench, you have to add a new reader to start things off. We've got a new zoom slider tool here in the Workbench, which makes it a little easier to zoom in on the workflows that you're working with. So that's good. I'm loading in here a CSV data set. It's a non-spatial data set, so it's got just a lat-long column in here. And so I need to make that, spatialize that in some way. So I can add some transformers that will spatialize that data, a 2D point adder and a point connector which will string the points together into a vessel track. And then if you've got data inspectors connected into your workflow when you run Workbench, you'll get those up in the new inspector if you make that your default, and you can see different aspects of the data. So we've got 3 vessel tracks that we're working with in this quick demo here. One of the things we added to 2013 is a smart delete. So if you are a Workbench user, when you now delete something from the workspace, it keeps the connection here, which does have benefits that if you've got a larger workspace, because it doesn't disconnect attributes and things that you've been working on. And so that's kind of handy as well. When you're adding transformers to Workbench, there's the quick add tool. So that's been in FME for quite a while. And that has been enhanced to allow you to not just do the quick add, which is really just searching the transformer names, but if you hit tab, it'll switch over to a full search and do a full transformer search, which is the same kind of as doing a transformer gallery search over here. So you can play around with that a little bit. We're always working on adding sort of more tools in FME for working with databases. So of course you can always connect to a database by adding a reader and going, in this case, if we want to join to a non-spatial database, I can choose SQL Server non-spatial and pull up a table list of a vessel database, for example, and add that to my workflow here. And then in some way I might want to join that to my vessel track that I've just built with a 2D, with the point connector transformer. In this case here, I'm using one of the many transformers that we have for working with databases, and that's we're always improving on those, and I encourage you to explore those. The SQL executor, where you can throw pretty well any SQL call to a database, the inline querier, and the feature reader, a great tool if you want to do more sophisticated spatial queries, so always have a look at those. I'm using the new joiner, and many of the transformers based on our move to the Qt, we're giving an upgrade, and the joiner is one of them where we've moved away from a bit of a lunky kind of wizard approach and summarize that whole transformer into a single panel. So hopefully those Qt changes will make life easier for you. So I'm using the joiner, which is sort of an easier to use transformer if you're not really familiar with SQL and those kind of tools. That's a good way of joining data to a database. And again, if we run that and bring the results up in the inspector, we can look at the vessel tracks, and there we've got some additional information that we've merged in here, the vessel tonnage and so on. And if we want to have a look at the location of the points on the vessel track, you can just click on them and see where the actual coordinates are in the inspector tool. And then, of course, as you have to write out to an output file, we can do that in oops, there we go. Writing out to, in this case, a geodatabase. Esri is always an interesting technology to write out to because of the requirement when you're writing to Esri geodatabases to have to write out, you have to have an Esri install and an Esri license when actually FME reads and writes from that geodatabase. So a while ago, Esri released an API that allows people to access an Esri geodatabase without having Esri tools installed and without checking out a Esri license. So if you're a non-Esri user and people are delivering Esri data to you, using the file geodatabase, FME can read or write simple features to or from file geodatabases. We call that the file geodatabase API. I guess they're all APIs, but we couldn't find a better name for that. So the other file geodatabase is the ArcObjects API, which is the full-blown reader and writer for file geodatabases and allows you to read more complex entities like annotations and relationship tables and so on. But give the API reader and writer a go. It's a little bit more convenient than the shape reader and writer because that's another way of sort of delivering generic Esri kind of data because you don't have the problems with attribute name truncation and upper and lower case and all those issues. And the file geodatabase is very fast as well. I think quite a bit faster than working with shape. And so I think that's probably about all we wanted to show just on the FME Workbench. And so we can just move right over to our next part of our day. For those of you that are not familiar with FME and haven't been around us very much, there is a web page that you can go to, FME Getting Started, and encourage you to go there. It has kind of a nice way of leading you through how to learn more about FME, so if that's a good way to get started. And of course, the main thing is if you are an FME user already, encourage you to always contact us at support. We're always there to help you, and if you get stuck on something, please do talk to us. Okay, so I think that's a quick intro to FME Desktop. And then we're going to continue the morning with a round-the-world trip and have a look at what a whole bunch of other users have been doing with the FME tools. So let me just clean up my Workspace desktop here, and we are going to go around the world somewhere. All right, so how are we starting off here? So we're all going to bring up and talk about our favorite uses of FME, and Stuart is going to start off, I guess.
Yep, I'm going to start off. It's another little interlude, I guess.
Actually, here, wait, Stuart, go back one. Go back one.
I
have to do this part.
Yeah,
sorry. So this part here we have to do like this. Our mission is to seek out innovative FME users throughout the galaxy, sharing their stories and ideas to inspire you to take your data where no data has gone before. Okay, that's my part.
Thanks, Bill. Yeah, I don't think I could have pulled that one off. So. Didn't have the right accent there. Okay, so FME does 3D. The first story we're going to talk about is the Kansas DOT Division of Aviation. So they built a really cool tool, and their mission was essentially to preserve airport usability both for the air ambulance service and for commercial flights as well. So if we dig a little deeper into that, essentially what they want to do is, there's lots of development pressure in many cities around the world, and they want to continue to allow the developers to build, new towers, renewable windmills, things like that. But they also, in allowing them to do these buildings, want to ensure it doesn't encroach on airspace. So it's a safety issue here. Do these new buildings that the developers want to put in place, do they have any negative impact on basically planes taking off and landing? So even at the airport side of things as well, as demand increases there's more and more pressure for planes to land instrument only, so in very bad weather conditions. And in order for the planes to be able to land in bad weather conditions, they basically need to be able to ensure that there's nothing encroaching their approach. So what they've done is they've built a public online tool to illustrate the effects of a proposed vertical construction. So what they have done is they've built a Google Earth-based tool. So this tool is all online. You can actually go here, interact with this tool, and what it allows the developer to do is place their proposed development in 3D into the model. So they can drop a crane, they can drop an office block, they can drop a wind farm, anywhere into the 3D Google Earth view on the web browser. The tool goes back to the FAA database and checks to see whether or not that has any issues in terms of encroachment on flight paths. And it gives instant feedback to the developer as to whether or not they can site their development in that specific location. So it's a really cool tool. I'll show you a screenshot in a minute. So where does FME fit in? Well, it fits in, it actually generates 3D airspace polygons all around the airport. So it shows, where the planes can and can't, where the planes take off and land in 3D blocks. And these were derived from AIXM data, and there was really verbose FAA descriptions in that AIXM data. So it said things like, flight path is 8 kilometers long, 1 kilometer high, and starts at position X. So FME took that text information and, using the transformers, turned that text into actual 3D polygons, best representations. The other thing is FME handles all the updates. So this is really good because it ensures the Google Earth tool is fully up to date. So as the new, if there's any new runways added, then the Google Earth is updated. If there's, if the runway's lengthened, then the flight paths are lengthened. If a regulation changes, then all the polygons are redrawn. So that's good because it's all been tested, so there's minimal errors, there's no human interference there, and also non-GIS people can do the updates. So let's have a look at the tool. So this is what it looks like. This is the web browser. It's really cool. So this is Google Earth, and you can see here we've actually placed some structures in Google Earth. You see the 3D flight paths there, the landing and the takeoff zones. And then you can see we've placed a crane, a water tower, cell tower, things like that. So as soon as I place that tower, I get the check against the FAA database, and I get instant feedback as to whether I'm allowed to build that tower effectively. So here's an example of the text we're parsing. So below 7,000 feet, within an 8-mile radius of X. So we took that text and converted that automatically into basically 3D polygons. So imagine we had hundreds of these, we read them all in, we took below, we converted that into, a block, we looked at within 8 mile, and we did basically mathematical decisions on the text. The other thing is, as I say, it's a completely repeatable process, and they have actually already stopped a wind farm being developed using this tool. So a wind farm was actually approved using older FAA data, and then they entered the wind farm into this application, and because there was a new extension to the runway, and they wanted the instrument landing to be even more precise, this tool actually said, you can't build that wind farm there, that poses a safety risk. So it did actually already catch a potential risk there. Okay, where are we heading next in the world? Austria.
Guten Morgen. So, I won't do the rest of it in my William Shatner voice, and I realize if you're probably younger than 40, you didn't even know that I was referring to the great Canadian Shakespearean actor William Shatner when I read that other one. So now we're going to go to Austria, to our friends UVM Systems. And their story is an interesting one. What UVM does is they make municipality simulations for infrastructure proposals. So in other words, if we were going to, let's say, install a whole windmill farm on top of Grouse Mountain here in Vancouver, we could simulate what that would look like, get a very detailed 3D model of the city, and then you could go to a public library and figure out when you're in your backyard, how does the landscape change when there's a bunch of windmills up on top of Grouse Mountain? And that's what they basically do. Now, the thing is, they go from place to do this. They get a contract for Reuter or for name your Austrian place. Bregenz, is that the one that you said? So we're trying to come up with Austrian places. But anyway, they go to these different places, and for each place they go, they have to assemble the data very quickly. And it turns out FME is a very good tool for assembling the local data very quickly into their 3D optimized database. Once it's in their optimized database, then they can build their simulations. They did this by extending FME to write their own format. So they have their own specific proprietary format that the simulations run out of, and they were able to extend FME using our APIs to do that. So because they're doing this all the time as part of their work, they are in the business of optimizing that. Now, the first time that they did this work, the first city they did, they had a lot of work to do. They had to create these workspaces and build these transformers and these workflows. But the beautiful thing is, after they put that investment in for the first one, the next city was very fast to do. So they're able to turn these simulations around very quickly after that. They also do QA while they're doing the data assembly. So they can make sure that the data that's going in is correct. They can make sure that there's nothing ridiculous like buildings that don't have roofs and these kind of things, especially with some of the new geometry validation. You're going to talk about that later today, Mark? Yes. So stay tuned for the end of the day. We'll talk about geometry validation. FME can do this. All of this helps them be sure that when they've assembled all their data, they actually have things that are realistic. So here's one scene that you can notice from some, this is out of their software. FME was used to assemble this data, and in the background you can see those windmills in the forest back there. And then the residents can decide how much or how little they like that. Now, I never knew for the past 5 days that I could actually click this picture. And so I'm a little bit nervous. The others tell me that this is going to do something. And so, okay, something's happening. And so now where do I roll her head to where, Mark? 4 minutes. 4 or 6? I'm getting competing things. Okay, 4-ish. What's going to happen at 4 minutes? A bridge and stuff. Okay, so I'll hit, is it going? There it is. Wow, okay. So this is one of the, I've never seen this. This is fantastic. Anyway, so you can see that, whoops, it's a little bit, bandwidth isn't so great. But the idea is that they also have moving parts of the simulation. So in this case, FME assembled all the stuff and helped them lay the train, the proposed train in there. And now we're whizzing along in their software watching the train go. And does anything else happen? Do whistles blow or anything? This should be an intro for the CN talk. But anyway, it's not. So should I pause this then? Okay. Well, I will. Next time I present this on the road, I will know what to do. So I got to go back here. Whoops, that's not good. How do I get to my presentation, Mark? There we go. Okay, so you saw what it was. So again, to do this, they used custom transformers in FME to package up things that they reuse over and over again. FME has slashed their processing time because they can automate this data assembly. So when they walked in to do someplace in Switzerland and were throwing 2.7 million buildings, they didn't flip out because they could just run the automated process on all 2.7 and off they go. And so now, the good news is, wherever they go, whatever contract they get to do a simulation for a municipality, they're not scared of dealing with the input data that they're going to be given. So the friction is gone. That's one of the things I like to say, is that FME removes the friction whenever data is involved. That's just out of the issue, and so now they can just move on to doing the work they do, which is simulation. And with that, I don't know who's up next. You are, Mark?
San Antonio water, back across the Atlantic here, south of the 49th, I guess. San Antonio water systems, a more conventional use of FME, cleaning up some data, migrating that data from sort of a scattering of databases that they had to try and create a more enterprise GIS. And at the same time, what they had done is purchased Hansen, an asset management system, and so they wanted to move the appropriate data into that Hansen asset management system. In this case, they were entirely using the Esri interoperability extension. So all this work was done with FME technology embedded in the Esri interop extension. So the work they had to do was to bring together a wide set of data sets, their billing, access database containing bits and pieces, Excel, accounting in a different tables in an Oracle database, try and clean it up, try and get it all working together, and then get it into this ArcGIS and Hansen database. This is also an example of somebody moving from a CAD-based system to a more enterprise GIS. So they had to get as much out of that MicroStation CAD data as they could. So one of the things they were doing was taking the text labels in the MicroStation, trying to attach that to the features that those text labels are close to try and glean as much attribution they could from the MicroStation before it went into their Esri geodatabase. So they had this big data cleanup area, and they built quite a few custom transformers to do some of the QA and data cleanup. Anybody using custom transformers in their FME workflows? Anybody trying those? We've got a couple of shy people admitting that they are using custom transformers. Thanks a lot. That's great. So anyway, you can bundle up workflows and methodologies into a single custom transformer and repackage it, either just to clean up your complicated workspace or to share that methodology with somebody else. So these guys were doing that. And it also allowed them to give interesting names to the work they were doing. So they created a couple of custom transformers. One was called the Locatinator, and the other was called the Pointinator. Something to do with associating points with their water and sewer lines, and the Locatinator was something to do with locating their manhole covers or something. But anyway, that was the custom transformers they were doing. And so some of the other cleanup work they were doing in this project was point snapping, joining together the MicroStation tiles where the sewer pipes were cut across the sewer, and also doing some topology cleanup on that data as it came through. So the whole goal of the project was really just to improve the whole workflow that all their staff using this data in various ways could do it. So the accuracy of the data, so that the billing processes were more accurate, usability, so that their own users had better access to the core data that they were working with in terms of customer service and engineering and so on. And then just the accessibility of the data from an enterprise GIS, more reliable from a central warehouse, enterprise GIS and the Hansen database, I should say. So they had the several customer service centers that were working with this data, all could be viewing the same data sets. As I said, they did a lot of QA/QC to bring this data together. About 50 different data integrity checks were run and are ongoing. And so one of the things that they're doing now as an ongoing part of the process is to make sure that the ArcGIS database and the Hansen database are kept in sync. So the parts of the data that is replicated across there, they do a synchronization. I'm not quite sure whether that's a good thing to do or not. But anyway, it's a kind of an interesting use of FME with our LRS tools of using routing, routes, LRS, and measures to analyze linear features and road routes.
So given that I think 3 of the 5 cities I was in last week had blizzards within 24 hours of me being there, I was always nervous giving this one. I had to drive from Calgary to Edmonton, and I was thinking about this particular example. Now, the blizzard had ended, thankfully, when I was doing that, but I know that about a month before, there was a 60-car accident on Highway 2, which would have really screwed up the analysis, I would have a feeling. And that road there is as straight as can be, so it's not like chopping a hole through a mountain or anything else is going to help you that. So anyway, we're going to go to Japan. We're going to go nuclear here. And look at an example. Many of our examples involve Excel being used in some way or another. And what we learned as we toured the world looking for FME uses is that in many ways, Excel is the shapefile of non-spatial data. It seems like it pops up everywhere, and people are always doing stuff. So this particular example from Japan is interesting. It's a bit sad, but it's nice to see FME being used in a way to help a very sad situation. And what's going on here is using FME in a way to help estimate the amount of radioactivity in a variety of agricultural water supply areas so that you can figure out ultimately where we shouldn't be growing food and where we can. And so we're using FME to interpolate this data. And so what is this data? Really, it's an Excel file of observations of how much cesium concentration is in a variety of locations measured in X and Y. And what we're doing is just creating a surface out of that to interpolate or to figure out or guess what the cesium concentration will be in other places where we didn't measure. And so I guess the interesting trick here is that FME has always been able to create a 3D elevation model, and it's nice to be able to use Z again instead of Z. So anyway, where normally the Z value is what we use as input to the model, and we can create a terrain model for what we think the Earth looks like. But in this case, instead of putting Z in there, we'll put the concentration of cesium in there. And so we'll create a model that isn't of the Earth that we can observe, but an imaginary or synthetic model that is of the cesium amounts as we look over the whole area. So we create that surface model, and now once we've got it, we can then make at least a reasonable interpolation or a guess as to what the cesium would be anywhere that we didn't actually have an observation. And so then we overlay these on top of our irrigation ponds and figure out what ponds are bad and what are not. So there's two ways that this is done, through these different polygons that are called Thiessen or Voronoi polygons, as well as Delaney ones. And perhaps the best is just to show you these kind of things. So here's these dots would be where we have actually got measurements. These ones in the middle are the centroids of those things, and we're figuring out how much cesium would be in these various water bodies and agricultural areas. And so, and so basically, in the end of all this, they're able to give advice to the local farmers and avoid basically contamination in the food supply. So kind of a nice to see FME being used to basically help, although it is kind of a sad story. So anyway, let's go to a happier story in CN. Do we need to explain to this crowd who CN is, do you think?
You would have had to explain to me a week ago.
Stuart didn't know who CN was, but...
No, I'm joking.
You're going to fail your citizenship test.
I know, I'm going to get learning. Okay, so yeah, Canadian National Railway. They're a huge company, actually. I was surprised. They have a market cap of 32 billion, and they employ 22,000 people. So a big company. They actually manage 20,000 miles of, is it miles? Yeah, miles of track, both in Canada and down the Louisiana corridor into America as well. They also manage the rolling stock as well. They've got a huge amount of rolling stock. They even have a lot of kind of, vehicles and things like that to do all the maintenance that they manage as well. So CN use FME extensively throughout the organisation. It's probably one of the largest footprints of FME I've seen in any organisation. They use it in business intelligence, facilities management, real estate, engineering, asset management, geotechnical, law, and even somehow in e-business as well. I'm not quite sure of that one, but it does touch a large proportion of their organisation, their use. So what we're going to do is look at a few of the kind of most interesting and most exciting uses of FME within their organisation. Firstly, they also have a lot of real-time data as well, so we're going to look at how they use FME server with the real-time data. The first thing we're going to look at is LiDAR. So FME does LiDAR. LiDAR has a large amount of processing and the ability to read LiDAR data into the product. It gets more powerful every year. So what they actually did is, you can see on the left here, they collected raw LiDAR data surrounding the track. So they went out, I think they used what's called a high-rise. It's kind of a vehicle covered in sensors that they push down the track with loads of sensors on it. They collect the data, and then once they have the data, what they had to do is they just want to extract the track. So you can see on the left here, there's trees, there's telegraph poles, there's building outlines. They just wanted to extract just the track. So initially they were using another product, Civil 3D, to extract the track. They had that working, they had a process going, but it was very, very slow and it wasn't scalable. It took several hours, if not days, to extract the track. So the problem was there, if someone came to them, I've got 100 miles of track, can you process it? It took them exponentially longer to process. So what they did is they built an FME process to do the work for them. They invested that time up front to build the workspace, but then once it had it running, they could pump as much data as they wanted into it, and it took a matter of minutes to run. So you can see here on the right, this is the track that's been output from the LiDAR, and then the engineers could do slope and corridor analysis on that data as well. So actually, once they got it running, they did 103 miles of track from down in Louisiana almost instantly. It took about, I think, 15, 20 minutes to do the processing. So, now they can just throw LiDAR data at the FME Workspace and do the processing and load the data into Oracle Spatial. The next step is to add a real-time component to it. So what they're planning on trying to do is they're going to drive the high-rise down the high rail down the track, collect the data in real time, and then use FME Server to collect the data and load the data straight into the Oracle Spatial database as point cloud data. So, then the data will be in the database in almost real time. The engineers can run the workspace to pull the track out, and they can start working on the data almost instantly. The next part is, FME does real time. So CN have a huge amount of location-based information and non-location-based information in real time coming in. So, not only do they have all the scheduling, the train reporting, they have GPS data from every carriage, I think, not just the train, but every single piece of rolling stock. They know the location. And they have all sorts of information coming in, things like, is the sensor information, is the train connected to the train in front, things like that. So they have this constant data coming in, and they use the WebSphere message broker from IBM as their complex event processor. So all this data is coming into the CEP, and the thing is with WebSphere is it's not spatial. So a large proportion of that data they forward to FME Server to do the spatial analysis on the data. Let's take the GPS data from the trains coming in from all the rolling stock. So they have over 7 million points an hour coming in to FME Server. FME Server takes the GPS data and it does things like it adds value to the GPS data by joining to geofences and adding attributes onto the data. It'll do network analysis and things like that. And then once they've done the analysis, they then load the data into Oracle Spatial as well. So they use the LiDAR data comes in this way as well through the complex event processor. But they've seen a huge amount of value from using FME Server to process this real-time data. And 7 million points an hour is it's an easy number for us to do now with some new technology we've implemented at the workspace level. They also do several other tasks within the organisation. These are some of the highlights. So they do grid polygon cellular coverage analysis. So what this is they basically want to see if they look at their network, where on the network are their blackout zones. So probably in the Rockies, some areas in northern Canada. They want to have basically a map of the cellular coverage. So they use FME to do that. They also decommission SQL Server and move that to Oracle Spatial. So, that was over 300 tables they moved very, very quickly using FME. And here are the 7 million points an hour they're pulling with the GPS. They did all the point cloud indexing. And they also built a neat tool within AutoCAD and MapGuide. And so this tool was effectively, it used FME Server in the background, but the end user didn't know it was using FME. And what it allowed them to do is import data sets into those software packages that weren't supported by the software package. So let's say they could try and import a shapefile into AutoCAD, and FME did the translation in real time and loaded it into the product. So they used FME Server to do that real-time translation as well. Okay, so I think we're going to jump back to Europe now, and Don's going to go on.
Yeah. So one of the interesting things about the notification capabilities of FME is it opens a whole new world of possibilities. FME traditionally has done, pulling data from databases, or one could call it static data. Now with FME Server, you can start to pull in real-time data feeds. And so this is an example of one prototype system that was built by our partners in Germany to track and more efficiently use the riverways or the waterways of Germany to move freight. Okay, so basically what they have is they have an FME server in the background. It's getting a number of data feeds. One is on the river. They have sensors, water sensors, to know how high the water is. That's important for a number of reasons. If the water's really low, you have to worry about the draft of the ship, or that's how much is underneath the water. Obviously, you don't want to scrape the bottom. That's considered a problem. And so if the water's higher, you can put more on your ships. Okay. The next thing you have to worry about is they have bridges. So they have a static database of all the bridges. And with the water level and how much is in the ship, you can now tell if, how close it's going to get to a bridge. Clearly, hitting a bridge is, another one of these things that's considered not ideal. And so what they have is they have a number of feeds here. On board the ships, they have AIS, which is the onboard identification system, so they know where the ship is. They know its position, its course, its height and current draft. They also have a model of the on the river. They have a sensor network, so as the ship's moving, they know exactly where it is. And of course, a static database of all the bridges. Okay. Now, what this enables you to do is, it's all about efficiency. Once you have a system like that, you have much more confidence on how much you can put on a ship, because you know the level. When water is low, obviously you're going to always play it safe. But if you know exactly the depth of the water at all the locations and your ship draft, now you can put more cargo on that freighter, being confident that it's actually going to make it down the river safely. Conversely, if a ship's too high, you can tell the captain right away, and he can always take on more weight to make sure that he navigates the river. So just like the CN case, this is again about how can we use our networks, our transportation networks, more efficiently using FME Server, and also avoid potential disasters. In the CN case, if you notice the slope is changing on track, that's not a good thing, and you might be able to identify, we need to fix that right away because we could have a derailment. Here, it's okay. We got to take water. We got to tell the captain. We got to pull that ship to port because he's not going to make it under this bridge, or we got to pull it aside and take more freight off. Okay, and the way the captain's notified again is he registers for this, and he's going to get, with FME Service. Well, how would you like to be notified? Do you want an email? Would you like an SMS? Do you have an application on your mobile device? How would you like to be notified? And that's really what it's about. Okay, so the data feeds come in a number of fashions, and again, the OGC interfaces, SOS, SES, they're basically slinging XML documents, so we can connect to one. In the case of SOS, it's a polling architecture, so we ask the sensor for the data and get the XML, and again, ripping it apart to decode it is no problem. SES is a push type of sensor network, and again, we don't really worry about the XML package itself. With FME, it's very easy to do that. And so the big thing here is, this trigger notifications. Again, the captain doesn't have to be watching as much. People can think about other things. He's going to get notified if there's a problem, which makes for a much safer and more efficient use of the transportation network, which in this case the rivers. Okay, back to this side of the pond.
So yeah, back to Canada, and this time the City of Hamilton, the Public Health Unit. So the Public Health Unit, they're responsible for basically collecting data, analysing the data, interpreting the results, and then providing information to key decision makers on anything related to public health within the city. So they do things like, they look at things like West Nile virus, Legionella, and what they've had in the past is they had a manual process. They would, let's take West Nile virus, this is what this presentation is going to look at in more detail. They go out and they collect the information related to West Nile virus. They perform the analysis all manually. They have some data in Excel, some data in databases, and some data in GIS. And then they perform statistical analysis and they present the decision makers with an Excel spreadsheet saying this is our recommendation. So that took about a week to do, which was, when you're dealing with diseases and the spread of diseases and wanting to combat that, the faster you can move, the better. So FME got the reporting down from 1 week to 12 minutes. And not only was it down from 1 week to 12 minutes, but it was also much more accurate because there wasn't any human error involved. They built the workspace, they tested everything, they performed QA on the workspace, made sure it was perfect, and then next time they pump the data in, they know that it's all been tested. So, what do? Let's have a look at the West Nile virus in more detail. They go out, and the first thing is they collect all the data, so trap locations, habitat maps, mosquito count data, the water locations where the water bodies are, and also ward boundaries as well. So they do things like they look at and they count the number of mosquitoes, how much the mosquitoes breeding, what percentage of the mosquitoes are carrier of the West Nile virus, and they also take the location of the densities of the mosquitoes, because obviously it's highly spatially variant. There's many more mosquitoes around stagnant water and things such as that. So then they have the data in GeoMedia Pro, and they have some in databases, they have some in spreadsheets. So FME pulls all this data in, and what it does is it uses various transformers to produce a KML file for the end user. So rather than the decision maker getting an Excel spreadsheet, this time they're going to get a KML file, which is much more usable, as we'll see in a minute, because the tool's interactive. So this is what it looks like on the right. So rather than a static Excel file, which isn't spatially enabled, they can now click on the different points throughout the city and get information on how bad the disease is at the moment, what's the count of mosquitoes, how many of them are carriers, and they can kind of look at the spatial variance, so they can then decide, okay, where are we going to spend our money, where are we going to apply the resources to try and minimise this, or is the disease even a risk at all if it's a bad year for mosquitoes? So they're using a few key transformers here, which are quite interesting actually. They're using a statistics calculator, so this just does all, it calculates mean, median, mode, standard deviation, things like that. They perform all the calculations relating to the data in here. What they then do is they build up a JSON file again. So they're building up a JSON file, and they pass that JSON file containing all the data to the Google Chart API. So the Google Chart API basically takes JSON data containing all the bodies inputs, a web service, and it gives you back a nice chart like that. So it's quite powerful actually. The charts look good, they're highly readable, and it's minimum effort for you. You just need a JSON file there. And then once they get the image back, they simply write that image to a KML bubble using FME. So, it's automated a really, really repetitive task. Huge time savings, 1 week down to 12 minutes. The decision makers are much more happier. Not only are they getting the reports much faster, but they're also getting, it's in Google Earth, so it's a much nicer presentation of that data. They are now as well looking to do this for Legionella and other diseases as well. So they can apply the same logic and the same workflow and just change the data sources. And the key thing here as well actually is creative transformers do open up a whole new possibility, and I'll just mention this really because there's thousands of web services out there now, and you can really interact with any of them using FME. You've got the HTTP transformers, so the HTTP fetcher can make calls to any web service, you can authenticate as well, and you can get data back from those web services. So, any web service out there, as long as it has an API, you can use FME to interact with them, and that's hugely powerful. So just bear that in mind. If you ever come across a problem, you could do things like send text, make a phone call, all within Workspaces. You just need to hit the right web service. So that's worth bearing in mind. Okay, where are we heading now? Ooh, I like this one. Okay, back to Spain.
Gobierno de La Rioja. Or something like that. So this is some of our users in Spain, one of the states in Spain. We aren't talking too much about the use of raster data throughout the day, so this is a good example of somebody using FME to process raster data. And maybe we wouldn't go to a site and say people should process raw satellite imagery with FME, but these guys have been long-term users of FME, and so they were experimenting in this area. They were getting rapid eye multispectral images, good Canadian technology from our friends at MDA, I understand, micro satellites. And the main motivation, I understand, for this work was at the time, the rapid eye constellation was relatively new, and the image processing tool that they had that they were using hadn't been upgraded to have some of the formulation that they needed to get some of the data out of the imagery that they were looking for. And what they wanted to do is to process the data so they could get some agricultural, do some agricultural analysis on that. Bunch of things I had not really heard of before. Normalized difference vegetation index they wanted to get out, transformed chlorophyll absorption, reflectance index, and optimized soil adjusted vegetation index they wanted to calculate from this satellite imagery. So they had to do quite a lot of pre-processing and formulation on the data. They had to know exactly where these satellites were when they actually did to do this processing. So they needed to calculate the distance from the sun and the incoming solar radiation. So when she runs the Workspace, inputs all these different values, including the time and day that the satellite overpassed, the centroid of or the location of the satellite at the time it overpassed, to calculate the solar azimuth angle and the distance between the sun and the Earth. So they used the FME transformer, the expression evaluator, to do some fairly detailed sort of trig work on these inputs that they had entered to calculate these values. And then these were used, again, within the raster expression evaluator that was then used to calculate for each pixel in the image these three different indices that they wanted to get out, these vegetation indexes, to be used for the data analysis that they were doing. So that's the NDVI, Takari, and OSAVI values. And then each of those images, the indexes were put out to a separate TIFF image that they could then use for their processing. So they are grayscale images put out that they can then run through, I assume, some other image processing tool to do the vegetative analysis. So a kind of interesting use of FME using those raster expression evaluators to do processing on each pixel within the image base to do some calculations and come up with a different index from the raw satellite imagery. These folks at the state of Rioja are also, they are very strong FME users, and so they've also been playing around with our PDF writer, which isn't probably the strongest of our writers in FME, but they've produced some fairly complex workflows to produce PDF maps, and my understanding is that these PDF maps are entirely created from within FME, and so they have all the styling and the title blocks within these PDF files. So what they're doing is creating the PDF maps from their data warehouse. I think there's quite a lot of work to get this going, but the great thing is that it's a repeatable process. So as they update their data warehouse, all they have to do is press the button and say, I want a map sheet for this area, and get that data out again and produce a new map. So I think that's really interesting that they've gone to the effort of using our PDF writer to get to that level of sophistication for their cartographic output.
Okay, thanks, Mark. So this one again is going to talk about FME server and getting data in and out, and it talks about a big area of one thing that you can automate very easily, and that's the QA/QC. And Stuart's again going to show some of that this afternoon. So SynCAD was responsible for building a geospatial data warehouse for the U.S. Army. And the idea here is they're going to get data from a wide variety of sources. Well, when you get data from a wide variety of sources, you want to make sure that all the data adheres to your standards so that when you load it up into your geospatial data warehouse, it actually meets the standards and you're loading up really good data. So what they did here is they got data in a variety of formats. I'll go next slide here. So they got it in enterprise geodatabase, personal geodatabase, file geodatabase. I'm sorry, and the enterprise geodatabase is what they're reading their current data from to make sure it all matched up. Now they checked the data in three ways. First was the metadata. So along with this data submission was the metadata. So so the first thing they QA'd was the metadata, making sure, which of course was in XML. You got to say XML, okay? Which was in XML, and so they would validate the metadata, making sure all the required fields was there. The second thing they did with the data is they used a schema reader. Now the schema reader's been in FME for probably, let's say, 3 releases. It's not a well-known reader, but what it enables you to do is for any format in FME, you can actually get the schema information. So you get the attribute names and the attribute types, and they would check to make sure that the attributes that were required were there and that the types were what they wanted to load into their master database. And then the third thing, of course, they would do a number of checks on the data itself. If you had a field that was supposed to have only so many values, they would validate the fields were the correct values and things like that. And then what they did is, again, just like the previous one with Whitestar, is they actually sent an email back to the data submitter that would give them a record of, was the feature valid, was it invalid, if there were problems with the data, what was the problem with the data. So then the people submitting the data could actually get a nice report and really know where the problem was in their data. There's nothing worse than submitting something and going, you just get wrong, right? And then you're like, well, what's wrong with the data? It's much better to be told exactly where the problems were. And so this is just some of the custom transformers they had here. And again, what they did is a nice thing about setting up a server as opposed to having a work file, an FMW, which you give to people, is you can update the QA process on the server, making it better and better as you go along. And now all the new submissions are doing it. By using custom transformers, they're able to modularize all the tests. So a different test would be in a different custom transformer. And then this is the nice spreadsheets they sent back. And as Dale mentioned, spreadsheets are really, you can think of them as the shape file for non-spatial data. There's just a ton of Excel files out there, and with FME you can read and write them very, very easily. So now FME goes nuclear, so Dale's going to finish this event.
Okay. So we're going to finish up here in Sweden and talk about how FME is being used to help decommission a nuclear power plant. So the scenario here is quite interesting and fun. We have a nuclear power plant that the Swedes built right across the pond. It would be kind of like if North Vancouver would build a nuclear power plant, and we'd be sitting over here in the convention center, and every morning we could look and see steam coming out of there, and we were in Copenhagen. So it's just across from Copenhagen, and they maybe did this in the 60s just to give it back to the Danes a bit for all that pillaging and so on that went on in the Middle Times. I don't know. But in the modern times, they decided they'd throw a goodwill gesture to the Danes and take this thing down. This place never had any incident. It was safe as can be. And so for the last 7 years, it hasn't been used. It's been shut down. But it's semi-staffed because you can't just sort of walk away from it. And now what they want to do is ultimately dismantle this thing. And so what will be left is basically just basically a park or something like that. So what we're going to do is take this thing apart. Now the problem is that the stuff in there that's contaminated, you need to load up on barges and take far into the north into somebody's backyard and bury it 1,000 feet under the ground. And the stuff that isn't contaminated we can recycle into IKEA furniture and Volvos. And so the thing is, it's way cheaper to do the recycling than it is to bury the stuff. And so you want to make sure when you're taking this place apart that you've divided it up appropriately. Now, because this thing is so old, there were no 3D fancy pants models of the place. What we had was a variety of inputs, but in particular what we had was basically some primitive CAD drawings of every floor in 2D. Curiously enough, every door in a nuclear power plant gets a lot of attention paid to it. And so every door has a brass plaque hammered into it with an ID number, and we have, you guessed it, an Excel spreadsheet of the XYZ location of each door. So we kind of know where the doors are then. That gives us something. And the last thing we have, which is quite fascinating, is another Excel spreadsheet where they did raster mapping. And so what this means, it's kind of like the old battleship game. Under the C5, we'll put the number 8 in there, and that means that it's asphalt, and C12, we'll put the number 15 in there, and that means it's a pond, and so on. So you have a raster map in Excel. And so we've got these 3 ingredients, and we wave our magic wand, and we use a little bit of FME, and we say olive, peanut butter sandwich, and we get this. And so the customer was very, very excited to finally see this because, in fact, they'd never seen a 3D model of the plant before. Now, this is actually being rendered inside of FME's viewer, but of course they can go out to 3D PDF for them to look at, as well as 3D DWG. And so this was a couple of weeks of work assembling that data into the 3D model. Look at it in this way. Now, why? What's the point of this? Well, because I said we've got to figure out what parts we're going to recycle and what we aren't. We can then go in this 3D model, and every place where we've taken a sample, we can go and put a little cube there and then light it up, color it by how hot that was or not. And it turns out our human brains are very good at being able to see patterns. Whereas if we just see that in an Excel spreadsheet, as wonderful as Excel is, it's a bit harder to notice. And so you can decide where should we do more testing and where shouldn't we, what areas can we carve off and categorize in one way or another. This particular spot here that's red, I think might be an area of concern. And so you'd want to do more investigation around this. Now, a couple of side notes to this thing. Taking samples is very expensive. That's also why they're doing this, because you don't want to just carpet bomb the whole place with samples if you don't need to. Why is it expensive? One of the interesting things is that there's actually more radiation around this place from Chernobyl and Chinese nuclear tests than there is from the work that went on here. And so, to some degree, we could make this all into York chairs and we'd be fine. Because really, if you're getting wood from Northern Europe, you probably have some Chernobyl stuff in there. But of course, they do want to be very careful in case there were any areas where there was actually any contamination at all. In reality, it appears as though the place is really as clean as can be. And it's so clean that I was actually able to visit this place myself. I know every woman's dream is to go and tour a nuclear power plant, and so I was able to take my wife along with me. And she was really excited. We got to put the hazmat suits on at the beginning and wear our own personal little radiation meters as we wandered around in there. And all these doors were kind of like going into a prison. Wham! The doors slam shut behind you as you make your way in. And we wandered around there. It was really a fascinating experience. To see. This place here is the only nuclear power plant that actually had a natural light in the control room. There's a window in there. All modern ones don't have a window. But here you can sit in the control room and see the nice countryside of Sweden. So that was kind of fun. At the end of the tour hosts, these guys are quite funny. They look at your radiation meter and go, they give this sort of faint thing and say, yeah, no, it's fine. And so that is sort of a little bit of humor inside the nuclear power plant. And I told my wife, though, that at the end, the exciting part would be the gift shop, where they have plutonium earrings and things like that. But it didn't help. So anyway, that's our trip through Sweden. So this place here will probably be torn down all gone in about 15 years. It is a massive engineering project to take this place apart and then ultimately end up literally with sod and grass where it's going to be. And there's a few of the gentlemen there that started their career as young engineers on the first day, and they will be there to put the last piece of sod in on the last day. And they are very excited to see the 3D models. They've worked in this place for what it would be like 30 years-ish, and never having seen the place in a computer and now to be using modern technology, they're very, very grateful and excited to see that. The other thing is, this technology is likely to be used in other places. There's a lot of older nukes that are going to be retired. In fact, Fukushima was on that path. Sadly, didn't quite get done in time before the disaster, but this is going to be happening around the world, and we'll look to see FME being used there more. So anyway, they'll be also looking for ways to continue to use vintage data. There's other aspects to this story. They've invented a technique they call smart papers, which use FME to print QR codes and kind of maps. They go around with a pen and mark things in, and then they put this back into a scanner and use FME to read that and place assets back in the model. And so it's a very ingenious technique that some of our Swedish friends have. We'll just finish up now before our break with a little bonus from Norway. And I saw on the Twitter stream that some of our friends that can't see unfortunately, I guess the live stream is not working. So we've got all these people out there live blogging about nothing, I guess. And it'd be interesting to tune in to see what they can chatter about. But But anyway, so that's why it's good you came here. You're the only ones actually seeing this. But they were saying that they got the Google Hangout was busy talking about FME and Minecraft, so we can do the same thing. This is a bonus thing. It just came in last week. We're going to find out more about this, and it'll be in part of FME. If you don't know Minecraft, that means you don't have somebody between the age of 10 and 15 in your life. If you do, you know this. In fact, I was told by Bola that the beta testers of this were his 12 and 13-year-old sons who tried this out. But ironically, what's gone on here is FME has been used to prepare data for import into Minecraft, and the result is the first ever combined land and sea terrain model of all of Norway being seen inside of Minecraft. The issue with Minecraft is you do have a concept of water, and you have a concept of the seabed underneath, and of course the land above. And in the game, which is an incredible visualization environment of cubes, if you don't know it, it's modeled the whole world in meter cubes. And then the cubes can have some properties, but the water cubes you can go down into and look at the subsea surface. You can come out on top of the land. And so Bola has done this. We will write this up. A year from now, you'll hear more about this. If you are a Minecraft person, that URL actually gets you the map. And one of my beta testers at home was showing me it as well. It is a pretty substantial data set, which gave his computer a bit of a run. But anyway, here's some scenes. We'll flip through a few scenes of this. And I won't try to pronounce these. But anyway, these are different scenes of Norway as prepared by FME and then visualized in Minecraft. So there we go. Here we are at night. Looks like we've got a little bit of a cubic moon thing going, or else it's a board ship that's coming in. But anyway, so there we are. Again, some other fjords. Here we are looking at it from the top down. A little bit scary here at night when the spiders come out in Norway. Here's the sunrise. Looks like a frozen part of the country. Here we see it zoomed way out, so you get a sense of the detail and the expanse of the model. So this is a lot of stuff. We're zooming down in. Here's one of the members of the Norwegian Mapping Authority out doing a field study. And here's some of the highlands. Again, the trees are being modeled somehow in this thing. Here we look at, again, some of the fjords, pretty steep things. And that's the end. So a quick little look, a very innovative use, taking FME to grind data and put it into a kids gaming thing, which turns out to be a spectacular 3D visualization environment, if you don't mind things being a little bit cubey. So I think that's it. By my count, this is FME 2013 hitting the road, yep. And this is our Out of This World Tour, and we're hitting the road, and we're starting by talking about the fact that FME 2013 had just a lot of stuff in it.
Too much stuff to talk about everything. Yeah. How many things were there that we thought were user significant?
I don't even remember. I guess if I do this,
there you go, 741 things.
So the problem is, at SAFE we have a staff of, I think it's got to be 40-ish developers, yep. And then another 15 or 20 technical staff and pro services and yep. QA and testing and so on. So yep. It's very heavily oriented to the technical side. And so as a result, we crank out a lot of stuff. And it's a little bit hard for us to summarize all that. We have, like, what have they got, 71 minutes?
That's right.
Minus 5.
Minus 5.
So 66 minutes. Yeah. So that would be just a few seconds per item if we were actually going to go through all of them.
Or we could go a lot longer.
We could. Yeah. We could go into a marathon.
It would sort of be like a cricket match.
Yeah. That's right. It'd be as exciting as well. So anyway, we are not going to go through all of them. We did make a word graph that kind of highlights a lot of things. I know Don is upset about the vote splitting.
I've already lodged a complaint about XML, because XML is getting a bum rap. Although if you look more closely and dig, you'll see that there's a lot of work on XML. You got the XML templater. Well, KML is XML. AIXM5 is XML. And then there's a KML.
GML. How about the GML by the W here?
Yeah, that's another XML. So there's actually lots of XML.
So it's been fragmented.
It has been.
Yeah. But if you can see, the fragmenting also happened to our CAD friends, because there's Real DWG, ACAD, DGNV8.
Yeah. So CAD to GIS is still a huge, huge area that we continue to work on.
Yeah, and of course the majority of our effort, or at least the check-ins or enhancements, are in Workbench, and the good news there is that affects all of you. Because if I go and make some new fancy 3D inverted cell reader for DGN, there's only a few of you that are into 3D inverted cells.
Yes.
But if I fix something in Workbench, it really should apply to all of you, so we do recognize that as well. So here's our splash screen. Just out of curiosity, how many in this audience are using FME 2013 already? Oh, there's more than many of the places, but I know many of our users live under a harsh cloud of IT tyranny.
That's right.
Sorry, Sorry, one of my IT guys is here from SAFE, but we like to make fun of the IT guys on the road. And,
Yeah, that's right. And everybody likes to make
yeah,
fun of
it's
the
a
IT
very
guys.
popular joke.
So this is our splash screen group, who's a very large group, actually, at
Yeah.
SAFE. We take it very seriously.
That's right. Yeah. So, but as usual, Don and I can't decide which one we like the best.
Yeah, yeah.
Actually, we do have somebody asked on Twitter if we have a 3D model for download of the zipster.
We do.
Yes.
That was probably used to make that puppy right there.
Yes, that's right. We just need to use the scaler and hit it all by 0.25.
That's right. Those are all hand-painted, by the way, so each one's different.
Every single one is different.
And you'll notice Dale and I pointed out that for SP2, the splash screen is going to be updated. And you might ask, well, why? Well, look at the rocket guy here. He looks kind of unhappy. And look at the lizard here. He doesn't look like the happy. And you can't have major characters in your splash screen not being happy. So when you get SP2, look at the splash screen.
We're going to turn that FME logo upside down.
Yeah, that's right. Or get rid of the eyes. Or maybe you'll be holding balloons or something. I don't know.
Anyway, so that's one of the screens. But as I say, we couldn't decide. So this is one of the bonus splash screens.
That's right.
Has anybody seen this one yet? Oh, Don has.
I have.
Oh, there's somebody. Hey, we should give him a... Can you just run out there, Don, and give him a spork?
I'll give him a spork.
Give him two, actually.
I'll give him two, in case he has two kids. Okay.
That's right.
There you go.
So, because almost
Excellent.
nobody ever admits to seeing it.
It does make you feel good when you see it. Like I know last night when I was playing around with FME in my hotel room.
Yeah.
Hey, up came the other splash screen, and I just slept so much better.
Yeah, it's nice. And here's another one. Has anybody seen this one? Now, oh, you've seen it as well. Well,
we're going to give him the big spork. We'll give him the salad one.
The salad spork.
If you come back next year, you might win the other one. Then you got really good salad sporks. You're welcome.
So it's very rare. You're the first one out of like 900 or almost 1,000 attendees that's seen both of them.
And how many FME logos do we have in our regular splash screen? As I used to say at BCIT, hint, that meant that was going to be on an exam question.
Yes.
There's 4.
Is there really?
Yeah.
Okay.
But still, it doesn't matter how many hints you give, there's still the bell curve. It's kind of interesting.
Okay, so anyway, that's that. I'll just take a quick detour for I know some of my friends that are... Roger, is the live stream working or not? It is.
It is.
So that means James Fee, I can say this one's for you.
That's right.
Mark hinted at it.
Yeah, and this explains why all the time we spent on Workbench, a large part of it is a part of this.
Yes. So this is a Macintosh task switcher thing. And so let's go over here. Isn't that logo nice?
That's a beautiful logo.
Nice
is
icon.
That task switcher thing, is that a technical term?
Yeah.
Okay.
And so then we can flip, and here is Workbench running on the Mac.
Yeah.
And so I was on the plane and I felt like doing a quick workspace to do some QA actually on FME itself. And so it does its thing, and actually it worked.
Yeah.
It all just worked, and we can get the parameters here, and they kind of have a Mac animation thing that goes on, and there's still some tuning needed, but it's starting to work. So that's that one, and we can pop over. The data inspector actually works quite well as well. So we can
and that's why we're rewriting the data inspector. You might wonder, why didn't we just extend the FME viewer? Well, the FME viewer is built from the ground up to use Windows technology, so we're redoing the data inspector.
I would say, Don, it was optimized for Windows technology.
I would say that.
The old one.
We'll say
the
it was
old
optimized.
One was.
Yeah.
So anyway, there's the viewer in all of its glory, and it does its thing, and we can see this and whatever. Yep, it's good. Okay, so anyway, that's for you, James, and all we got to do is figure out how to make an installer out of that. And whoa! There we go. That's why we haven't given it to anybody
look
yet.
At that. Ignore. Just ignore. Or report it. You should have clicked the report button.
Yes, that's right. So anyway, well, James, it's not quite ready for you yet, so you'll have to wait.
Okay.
All right. So that's that.
Faster.
Yeah, we always talk about this.
It's got to be faster or we don't ship. It's considered a bug.
Yep. I always say
that. And if anybody has a workspace, and I always say this too, if anybody has a workspace that runs slower than the previous release, let us know. That's a bug, and we want to fix it. So there you go.
So we did a lot of, we treat this very seriously. We have these fancy graphs that are made, and there's...
Yeah, and you can see wherever we got slower, the next one was immediately...
Right. So we try to go up is good in this graph.
Up is good.
Yeah, up is good in this graph. So we track the performance of our small or our short tests and our long tests, and there's several thousand of these. I never actually know the number. What number do you say?
I say there's 4,500 we run every day, and then there's another 4,500 we run on the weekends. So a total of 9,000.
I think you're safe in saying that, because I actually think the number is higher, but I don't want to. I think it might be as many as 7,000.
And they keep adding them all the time.
So anyway, we do lots of testing, and among that testing, we test performance. We try extremely hard not to have FME get slower.
Yep.
Of course, when you upgrade your computers, then you just keep getting faster.
That's right.
So that's that. This is the best recorded case of FME.
Of a single test, that's how much faster it was?
That's right.
Yeah. So you shouldn't expect that.
No, that's 642 times faster. What they were doing here was an interesting kind of an odd case, but they were dumping a database of a bunch of features, writing microstation design files, and they were doing a data set fan out. Now, if you don't know what that is, that's when you're using an attribute as part of the feature to determine the name of the output file.
Yep.
As they were doing a data set fan out, which was resulting in every single feature being in its own file. I'm not sure why they wanted to do this, but hey, the customer's always right.
That's right.
And so the problem was it was very, very slow to do this, and we tuned it up, and so it took a few seconds. The issue was that we were having a lot of overhead to make all of these design file writers, which was very great compared to the cost of actually writing one feature.
Yes.
So if you're doing large fan-outs, hey, it's a benefit to you. If you're actually writing to a single file, you're still winning, but it's so tiny you won't notice.
Yeah.
Something that took like half a second is taking a quarter.
A quarter?
Yeah.
Okay.
So there we go. That's the best. You should remember that because this could come up later. Would that be one of your hints, Don?
If it came up later. Does this one come up later?
It does, at least on the West Coast.
Oh,
it did.
okay. Well, then it did in the East Coast, too. Yeah.
Okay. So that's good. But really the question we're here to answer today is FME faster than a 2012 performance Tesla Model S?
That's right. And that's one fast puppy. It goes from 0 to 60 in 4.4 seconds. Those of you who came last year might have remembered us comparing the speed of FME to a helicopter in FME 1.
Yes.
So now we're going.
We're stepping it up a bit.
That's right.
To a 400 horsepower car.
Yeah.
So this was great because it gave us an excuse to actually buy a Model S.
That's right.
And to do this
it was
testing.
research.
It was research. It's part of our SRED grant, actually.
That's right. That's
so
right.
now,
so how do we tie this back to
Mars? We
Mars?
have to tie this into the rest of our thing is about a space thing, and we have a little bit of a weak tie in here because SpaceX is a company that is doing private launches to the space station.
Yep.
And so that's the CEO of that is a guy, the PayPal billionaire Elon Musk. If any of you saw the Iron Man movies, particularly Iron Man 2, he was actually in Iron Man 2 briefly.
With Larry Ellison, right?
Yep.
Yep.
He's in there, and I don't think he'll be in Iron Man 3 though.
I don't know. I haven't seen it yet.
Yeah, but actually, the screenwriter for Iron Man did, to some degree, pattern Tony Stark after Elon Musk.
Ah.
And he's a little bit of an inspirational. So anyway, Elon Musk is the SpaceX CEO. His goal is actually to get to Mars, ultimately, and fund it by doing private things, basically providing contracts to the U.S. government in the meantime. But he's also the CEO of Tesla Motors, which is an electric car company in California. So that's our tie-in. It's weak, I know, but let's go with it.
Yeah, and Elon Musk, does that quote come up?
It doesn't.
Okay, Elon Musk says he wanted to die on Mars, but not on impact.
Yes, just
that was a
preferably
quote
not.
from him. Yeah.
Preferably not on impact.
That's right.
So anyway, well, what are we going to do? If you were here last year, even the year before, Don has been talking about this for at least 2 years, maybe more, about the Internet of Things and how all the devices that are out there are starting to become connected. And the number of these is going to explode to, I don't know, some kind of billions, right?
Yeah, because I have a plug at home.
Yes.
A Wemo, and you can buy it at Home Depot, costs $20, and you can control your lights in your house now with your iPhone. Okay, so you know if you can put on all your switches, and then when you're not home, you're going to shut off the whole thing. Makes your wife really happy to be in the dark.
Another good example is the Nest. If you don't know about this, you should. It's just Nest.com, and it's an internet-connected thermostat that is really, really cleverly done. You can control it also. You can turn the heat off on your wife as well.
I can.
So you can do that sort of thing. But seriously, it learns from your behavior. It'll report to you what's going on in your home. It'll sense if you're home today and you weren't yesterday. It'll say, okay, I'll keep the heat on for you. But if you're gone, it will turn it off. So these are the kinds of things, more and more and more, that you saw the CN guys. They said that every single car has sensors on it that are reporting in. And those, the one you did about the boats.
The boats in Germany.
You know, I was commenting that yesterday is the 101st anniversary of the Titanic sinking.
Well, you know what the Titanic and the Leafs have in common?
No.
They're both great until they hit the ice.
Okay. That's a little slam for our Toronto Maple Leafs fans. But, oh, look at that. Spontaneous applause here.
That's right.
For that joke.
Yeah.
To say that if the Titanic would have had some internet-connected sensors,
it wouldn't have happened.
It would have been A-OK.
Yeah.
But anyway, the car itself has a REST API. And so that's what makes it interesting. So if we click this, we should come up here, and people have reverse engineered.
I didn't even know I could click there.
Yeah, there you go.
There you go.
You can look at all the REST calls. So we can do things like down here, flash the lights or honk the horn, or more dangerously unlock the doors. Some of these kinds of things can be done, start up the air conditioning. But you can also ask it what it's up to. You can find out what is its charge state, what's the drive state, and so on. So we can ask the car different things, and it will do that. And as we've been on the road, we found out that it's not just the Tesla that has this
A Buick has this, apparently, and
Yeah.
a Nissan Leaf.
Right.
So more and more. Yeah.
Right. So anyway, we're using the car as our example of something on the Internet of Things. And that's going to let us begin to. Oh, but we're not going to do this Tesla,
No,
right, Don?
no,
So
no.
this is somebody else's Tesla.
That's
is
an
actually-
interesting option.
Sergey Brin, who is the one of the co-founders of Google.
Yeah.
This is his Tesla, and this is sort of what happens when your friends have unlimited funds on April Fools. But what I thought was funny, they have the fuzzy dice in there, the Batmobile sort of wings, and the eyelashes kind of weird me out. But I thought this was really interesting. They also have chrome rims.
Look at that, chrome rims.
So it shows that they spared
Wow,
no
that
expense.
is an expensive April Fool's joke.
Yes,
Yeah,
yes, indeed.
yeah.
So anyway, we're not going to track that one. We're going to track another one.
Yeah.
And so what we're going to do over the next 55 minutes
Yeah.
is use FME Desktop to author a complete workflow to track and do some value add on the movement of the car. And of course, we know you may not care. In fact, you may even hate electric cars, and that's fine. You can imagine that we'd be tracking something else, let's say like a Hummer.
That's right. That's right.
If you want to. So
you can get a lot of sensors on a Hummer.
Right. And in fact, actually, there's a company called Automatic.
Yeah.
If you go to automatic.com, they're selling a little device that you can plug into the, what's that thing called? That
I think it's like the sensor port
The
or something.
diagnostics
Yeah, the
port?
diagnostics port.
You
That's
can plug this into the diagnostic port of almost any car, and then you have an iPhone app, and it'll report to your phone all kinds of information about what your car is, any of them.
Yep.
So it doesn't even have to be, if that app then has a REST API and is reporting, you could do this on just about any vehicle at all. But the interesting thing is that we're going to be transforming spatial and non-spatial stuff.
Yep.
We're going to be doing this in the cloud this afternoon.
Yep.
Stuart is going to tell us more about what's going on behind the scenes there.
Yep.
And the other thing is, all the stuff we're showing, anybody could do this with enough time and enough code. But I don't know that two sort of aging CEOs that are fragmented in their time.
Are you aging?
Well, one's aging one and one young one.
One's getting more mature as the days go on.
Can put this together. We put this together in about 2 weeks of time. In our spare time between running safe.
That's right.
And
That's right.
with sort of an increasing amount of activity as we got closer to the World Tour.
That's right.
So we did have a little bit.
And we had another constraint. We wanted every workspace to have 10 transformers or less, so that you could believe that you could do it. And we almost did it. And there was a few where we just got crazy because we wanted to make pretty maps. But all the workspaces generally have 10 transformers or less. So
we put together this whole system ourselves kind of in our spare time, which kind of illustrates that it's very easy to make use of these web services and all these other things in FME 2013 and produce something useful. Now, I do have to call out, where's my friend Dimitri?
There he is.
There he is. Dimitri did do the last two workspaces we're going to show, or two near the end, Don and I didn't do.
That's right.
And,
And they do amazing things.
Yes, so we'll save those for the end. So that's what we're going to be doing, is setting this all up.
Yeah.
And so just to recap,
Yep.
we're going to just use the web to do this.
And everything's running in the cloud, FME servers in the cloud.
Yep.
Well, Stuart's going to talk more about that this afternoon.
Yep. So here we go. So let's just recap. We've got ourselves a Tesla, and we've got an FME server.
Yeah.
The server's running.
In the cloud on AWS.
Right.
Yeah.
Oh, yeah.
We're using PostGIS 2,
Uh-oh.
2.0. What happened? Oh, this crazy box. Maybe did I bump it again? I tend to swing my arms as I'm talking, and there's a nice switch
We need
down
a
there.
little.
Sorry about that.
Let me just put a hat in front of there.
Yeah, put a hat, protect it. Okay.
Okay. So anyway.
And that's a new format of FME, PostGIS 2.0.
Right. And we could have even used some of the advanced features if we felt like it.
That's
but
right.
I made a little asterisk there because we're using PostGIS only because it was handy. You could use geodatabase. You could use whatever you wanted. You could use SQL Server on Azure.
Yeah.
Would be a handy one to use. We do a good job of that. We could be using Google Fusion Tables. And usually, I would mention at this point, we could even use GME, Google Maps Engine.
Right.
Which is a new thing coming in FME. If you don't know about that, that's a thing coming from Google. It'll be part of FME 2013 SP2.
It'll be SP2?
Yes.
Ooh, that's exciting.
In fact, it's working in our office right now. We can do everything except create tables. So if you've created it ahead of time, you'd have to. But we could have used GME to do this as well. So anyway, the database, as Dawn has once said, at least I thought you said this, and I tell everybody you did.
Okay.
That format is irrelevant.
It is irrelevant.
Yeah. So we don't care. So use whatever you want.
Yeah.
All right. Now, Don, you want to talk us through how this works?
Sure. So basically an FME server, everything is around a topic. You can think of it as an address. So here we're building a Tesla tracker. So everything we're doing is goes through the name Tesla. That enables servers to do many things. So if you had another workflow that was all about graffiti, you could have a topic called graffiti. The first thing we're going to do, obviously, is we're going to write a workspace that's going to take, as these Tesla feeds come in, we're going to write them to a database.
Right.
Yeah.
So basically what goes on is that this topic concept is like a relay. And I found out from Don that that was actually a working name for this.
Early on.
Early on.
Yeah.
So we're going to set up something that's going to ask the car, hey, where are you and what are you doing? And we will pull it. Unfortunately, the car doesn't have a push.
It just pushes to Tesla.
Right.
And then we talk to Tesla.
That's right.
Yeah,
so we have to ask the car every minute what it's up to. And then when we find out, we're just going to say to the FME server, here on the topic or the relay Tesla is what the car is up to. And then what we'll do is attach a number of things that will happen after that.
Yeah.
Now, the obvious one is storing the data.
That's right. That's right.
Okay.
So there you go.
Yes. So just to recap, the car is letting Tesla themselves know what's going on at all times. And instantly, when you buy a Tesla car, the biggest part of the purchase agreement is about a 3- or 4-page legal agreement allowing them to watch how you're driving and what's going on. So they record incredible amounts of information. This is ultimately to help them service the car and learn and do better.
Right.
And hopefully it'll never be subpoenaed.
That's right, because you're in big trouble.
Yeah,
if
that's
they
right,
do.
because there's no hiding. So anyway, what will happen is that FME is going to pull information from Tesla using that REST API from the car every minute to find out its speed, and there's a handful of things.
Yep, heading, whole bunch of things.
Lat long and stuff.
Yep.
And then we're going to spin our PostGIS.
We're going to spin it into the PostGIS database.
That's right.
Like that.
So that's kind of the first part of the workflow. Now, Don has, I think, mentioned XML at least 7 or 8 times so far today.
That's right.
But hardly ever we've talked about JSON.
Yeah, even though it's done by the same team, and they do both.
So JSON is the web-friendly brother of XML.
It is.
And for most web services, you end up using JSON. The good news is for SAFE that all the work we did for the last 15 years on XML, all of that comes across and lets us slice and dice JSON very easily. So many of the same techniques and ideas apply. So again, JSON really the language of web services, and FME able to consume them. So let's go and first of all look at how we're going to use that REST API. So come on here. Don't need that. And I've got this is actually the workspace that sort of starts it all, really.
That's right.
And this goes out. And so how are we doing it? The real key thing here
is first we got to log in.
Yes.
So Dale looked on his website there and found out that there was an API call to log in.
Right.
And so you simply copy that URL, and then we're going to do a post, I imagine, because you're going to send a body up there that has a password and user ID, and that's basically it.
So yeah, we found out that, for example, we had to put this is the syntax, and that was the hardest thing, actually. This whole exercise was fiddling around to get logged in. And there's different kinds of authentication that different websites use. As an aside, I really wish Tesla would use OAuth, because that would give us a token, which would be easier. But in case you use web services that use OAuth kinds of techniques, which more of them are going to do, that term is good. You're not going to get away without knowing that term over the next few years. That is the future for all these web services. And recently we had to upgrade our Twitter and Google Fusion Tables to do OAuth. But this is an example of a parameter where I'm gluing things together. In the past in FME, I'd have had a separate concatenator, but I can do it right in line. And while we're in here, I'll show that if I wanted to do something fun, I could take and, let's say, make my username always be uppercase. I could drag this in here and then just put the username in there, and now I could do that. So there's a bunch of string functions now part of the standard text editor that lets us do this sort of stuff right in line.
That's right.
So anyway, we log in. And again, this is the REST API call to log in. And then having logged in, we get our list of vehicle IDs in case we have more than one.
Yeah, and it's kind of interesting. This workflow shows a problem with the Tesla API in that whether you're successful or not, it says you weren't successful.
Yes.
And so, so what you have to do is just on the next call you find out. So we always ask for vehicle ID, and on that fetch we'll really know whether we were successful logging in or not. Now maybe that was a bug, maybe they did that by design, who knows? But
to discourage people,
that probably
it was discouraging, I will admit, when it kept failing over and over and over again. And we thought, well, let's just try it anyway, and it was actually okay. So that's one thing, though, to highlight. We added this concept of a rejected port to many of our transformers, so that again, when we started SAFE, we thought that all data was inherently good. And so if there's anything bad at all, we should just end the translation. With time, we began to be worn down and learn that data is inherently evil. And actually that we should not take it upon ourselves to end when something's bad. Instead, we'll let you know, and you can decide. So if you wanted to, you could, when stuff fails, in this case, we actually are going to just end the translation.
Yeah.
But we can do, in this case, and just carry on good,
Exactly.
as we used to say.
Exactly. Yep.
So anyway, we fetch the IDs, and then we fish out our car number. There is one guy that has 100 Teslas.
Is that right?
Yeah, it's the owner of Zappos, which is a shoe company.
Yeah.
He bought 100 of them because it's for some green initiative in Las Vegas, which is an odd place, I think,
Yes.
to start a green initiative.
It is. The whole
but anyway,
place is only there because of energy.
Yes. So I guess I got to start somewhere, and Vegas is as good as any. So now we go and we flatten our JSON to get our vehicle number, and then we go into this thing called the location logger, which is a custom transformer that's going to fetch the drive state of the car. So here, again, we're gluing together, if I do this, we're gluing together the REST call, so it needs the vehicle ID and then asks for the drive state. And once we get that back, we have some JSON, and we're going to then also get the battery state.
That's right.
And so this is, again, with the charge state call. So we get these two things, basically glue the JSON all together, and send one copy down after we wait for whatever our amount of delay is. Here we've set it for a minute.
That's right.
And we're going to...
basically going to loop.
It's going to keep on looping. So we're using loop, and this is all new icons for the looping. But so we're going to keep looping and asking every minute for what the car is up to. And each minute, we'll also kick one out of here that goes out to the main workspace. So we'll kick out the readings, and then what we're going to do is when we get to here, we'll ask the question, is the car moving? Actually, this is interesting. The JSON flattener will take that package, the payload we got from the web, and we'll flatten it out into these various attributes. So the state of the car, the speed, the latitude, longitude, heading, and so on. And then we ask the question, is the car moving? And Don makes use of a new feature where there can be spaces in ports. Did you know that?
Yep. No,
and they can be upper lower case as well.
Yeah, greatly improved.
And we have this nice sort of if then else thing. So if the drive state is D, we'll say the car is in drive. Otherwise, it isn't necessarily in park.
No, you could be driving in reverse.
And that's the only way I can drive without Don knowing.
Or it could be being towed.
That's true. I could be being towed.
So if your car's being towed, you wouldn't.
I wouldn't know.
There
used to be a guy back on the farm where I grew up. I remember one guy who backed his car 23 miles because the drive had broken and he was in a different town. He just backed her all the way home.
Wow.
So if that happened, you wouldn't know that that's what I was doing.
Interesting.
So anyway, we'll go ahead and run this thing.
And the interesting thing here, too, is if you're just consuming web services, you don't need FME server. Like, we're able to consume web services just as easily on the desktop as the server. Certainly, if you're creating web services, you need the server. But if you're consuming web services and there's more and more out there, desktop is all you need. So there's no need to buy a server.
So what happened, Don? It didn't actually work.
Is the car moving?
No, the car isn't moving. I think we were unable to get the vehicle IDs today. So
you changed your password.
Yeah, but I think I had it running earlier. But anyway, we may have to abort this one. There we go. It worked the second time.
Okay.
So it is. So the first time was the case.
The internet in here is a little bit sketchy, as everybody on the
we're
live
now
stream.
dedicating.
Did we just lose our live stream again? And
Roger, is the live stream okay? Okay,
good.
Well, that's good. We gave up some of our bandwidth
that's right,
for the live stream. So anyway, it popped up because the vehicle isn't moving. This is showing the table viewer. We can see where the car is parked, and that better be in the basement right here.
It better be, or...
I hope it is. And actually, we can take a peek here and see that I've got 193 miles. Unfortunately, the API is in imperial units.
Yeah, that's right.
So, and we had 77% of charge. So, okay, it's parked here. So that means we can't... Unless we went down there and went for a drive right now.
That's right.
It would kind of end our demo.
Yeah.
We could give the keys to somebody.
To Craig. He would love it.
Is he trustworthy?
I mean, we'll see if it really can do 0 to 60 in 4.4 seconds.
You know what? I heard a story that one guy opened up one of these things in a parkade and smacked right into the end of it because he didn't realize it would...
He didn't realize it couldn't brake, like, instantly?
Yeah, it couldn't brake as fast as it accelerated. So you got to be careful, Craig, if you take it for a spin downstairs.
That's right.
But
hopefully he didn't say, watch this, just before he hit the accelerator.
Well... They did test that the airbags came out. This was actually a Toronto guy. Anyway, so what we can do, what I did on company time, I don't think I told you that, I did on company time.
Wow.
I went for a drive with the car downtown.
And you didn't even take me with you.
It was after hours.
Those company hours.
Yes. So, so what I did was attach another Workspace onto the topic that saved a special little file for me of my drive.
Right. Was that SQL Spatial Light?
It was Spatial Light, a new format in FME, Spatial Light, a self-contained little database, very handy. So I've got a Spatial Light file here, and what we're going to do is we're going to simulate driving the car. And we use a transformer called the decelerator, which is just, because people said FME is too fast, we've got to slow it down.
Well, they said the Tesla's too fast, too. So you
just got to slow it down.
But you're actually
you know what else they
Tesla
say is too fast is the log file.
Yeah, that's right. So it's so fast now that, you know, in the past you could always watch it go by. Now sometimes for short ones it's just over. And we've actually had somebody ask us to slow down the logger because they thought that
it's just too darn fast.
And we won't do that.
I guess they were speed readers, used to read it as it was going by.
That's right.
But so what we're going to do is prompt and run, and let's see. We're going to play this back as if I'm FME Meister.
That's right.
And how far apart? What do you do? Like, what do you say, 25 seconds?
Yeah, let's go 25, 20 or 25
seconds. So really we're doing this a little more than twice the speed of real time.
So where you were doing 60 miles an hour, now you're doing 120.
Right. Okay, so this should make an interesting report at the end. All right, so we're going to start this going, and basically every 25 seconds, with luck, it's going to poke at the FME server and tell us tell the FME server the car has moved, and here's where it is. And I hope the internet works for this.
That's right. And anybody who's installed this will start to see in a few minutes.
Right.
They'll be getting alerts as this car goes whipping by.
As it comes by within 5 kilometers of your phone, basically. So that's one of the things that's been set up. So the first one has happened.
Okay. So we're moving.
If we're nervous about it, which I usually am, I've
been so scared I was going to close that puppy.
Yeah, I know. But I'm going to go and look at our database, our Postgres database. Did you ever do this in yours?
No, I never looked at it live.
Okay, so look at it live here. It's kind of scared on. So let's view the feature information. Okay, so with luck, it's hitting that database. Okay, we got 1 point. And that should be the safe office. If we had a background map in here, we would know that.
That would be so nice.
Yeah. So yes, we are working on a background map idea for the data inspector. You'll be able to configure that to anything FME can read. We're also going to have an option in there, so if you want to use ArcGIS Online to supply the background maps and you have an account, you could use ArcGIS Online and maybe other things too.
That's right.
So anyway, we got 1 point in there, and that's a nice thing, even though we've reported 3 now. So
that's okay. If you refreshed it, you would have saw them.
Okay. So anyway, we're showing that we did that.
Okay.
And we did this, I think. Yep. So, whoops, no, we didn't do this. Is this the part where we put in the database, Don?
That's right, because right now we just launched the logger.
Yes.
You showed the database, but we haven't actually.
Right, we've got to show you how we actually write the location to the database.
That's right.
So what we do is we have this workspace here, which is a very, look, how many, it's only 3 transformers?
5 transformers.
So
maybe next year we'll have a 5 transformer limit.
Right, so this workspace gets put up to FME server, and we tell FME server whenever any action happens on that Tesla topic, when you get some information on the Tesla topic, run this thing. And this one flattens that JSON to give us all the goodness that's in there, all these characteristics. And then basically we make sure that it's coming from the car so that nobody's
because a topic, if you could authenticate, you could send them.
Nobody's spoofing us.
That's right.
And then we make a Latin long point. And you fix up the date and time.
Just to split into 2 fields. And
then put her in the database. And so this one here is up there running right now. And so if Don will be able to tell me. Actually, I wonder how this works. So here's FME server in its fancy new user interface.
So you click on, once you log in, you click on jobs.
Right. And so there we can see that it's been running and stuff's happening. So that's good. Is it notifications where I show how this thing relates to Tesla?
That's right. So you see the topics there. There's Tesla down there at the bottom. And then if you click on subscriptions, you'll see for the Tesla topic, you'll see Tesla, you can see the...
all of these, right. So this one here is where it says that we're going to run that right location to DB every time that this is there. And you can see there's other things that are running every time the Tesla gets poked. And we're going to walk through all of these as we carry on here. So there we go. We've written to the database our location. We've looked at it. One thing that Don likes to do is send me an email every night at 2 a.m.
about where Dale drove that, or more correctly, where his car's been.
Yes.
So I also get that email because I wrote the Workspace, so I snuck in another address.
And it is kind of funny because while I was on the road last week, I could tell where every morning I knew where my wife was the previous day.
That's right.
So,
and it's also great if you check into a hotel and you give the keys to the valet. I mean, I'm sure no valet has ever taken a nice car for a spin.
Watch Ferris Bueller's Day Off, for example.
Exactly, exactly. So you get the summary of where your car's been. So.
Yes. I'm sure my wife was really excited about me watching that as well.
That's right.
So anyway, we can send this daily email, and the way that this works is it uses the scheduler in FME Server. So if we look at the schedules here, we see FME Server has one, and every day at 2 a.m. we're going to generate the hourly map. And we won't run that now, but should we take a peek at it, Don?
Sure. Let's have a look. Again, it's a very simple workspace.
Okay. Yeah. So let me see. I should get it from here. Generate the 24-hour map. There we go. Yeah. And so what this does, a couple of things. It's going to read the day's locations.
That's right.
Don has actually set this up in case there's many people's cars in there.
That's right. So each person's car would get a different email.
Yes. And so the first thing we do is we keep a historical record. I guess if we want to go back and
we've never used it, but it seemed like a good idea at the time.
If you want to go back and audit my timesheet, for example, we could do that. And then the other thing is we wrote a copy down to the bottom, and this is where we use FME's ability to delete things from a database.
Yeah.
So we set this up to delete where I'm just going to pop this open here, where the vehicle is the vehicle we've just read, and it's for the day.
That's
so
right.
Bang, we're basically creaming all the data for the day.
Yeah,
right there. And now the middle copy we actually do something with. You sort it. We connect the
So we make basically a trace of where the person's been. And then the hardest part is basically building the map.
Right. And so here we use this thing called the geometry extractor, which has quite a lot of options in it for basically taking geometry of a feature and giving it to you as text or an attribute. And so there's a whole pile of options. There's these different SMS things from OGC, which actually, when we send SMSs, they'd be handy. So you can get geometry like that. GML, many flavors to choose from, well-known text and binary. But today we're using the Google encoded polyline.
That's right.
We could do Esri JSON as well. If we were using ArcGIS server services, we would use that. But Google encoded polyline basically crams the whole line into a funny long set of A, B, C, whatever.
Yeah, letters.
And then we build a URL. So this is Google's URL for making maps.
So we found that. We just did a search in Google Static Map API, found the line we wanted, pasted it in, and away we go.
And so this inc thing tells us that what follows that is the ABC, whatever that encodes the geometry.
That's right.
And so then we call Google. This is an HTTP call.
Just using the URL that we just finished building.
Right.
And it's going to send us back an image, which we're going to store in an attribute.
Yeah. And I don't know if Don knew this, but I actually made this work on all platforms by... I had to use a little TCL here. We should put that in as a transformer to make it.
Does that have a Python option? Oh, you're using the TCL caller.
That's right.
See, this is a great example of where you would use TCL. Well, actually, we should have an FME.
Yeah, but we don't yet.
You know, but sometimes you need it, just like sometimes you need Python. And so if we really hated Python or TCL, we wouldn't have a TCL caller or a Python caller.
Right.
So sometimes you can do little things that are really quickly. And so that's what those are for.
Then we save it to disk.
I would have used Python, by the way, but that's okay.
That's okay. And then in here we actually set up the email message. So here I'm basically sending something to FME server saying, please FME server, send an email that has this subject, test the driving record for so-and-so on this day.
And you removed my email address there. You can have a comma separated.
I decided on, at least for the West Coast ones, I didn't send them to Dawn.
Okay.
So anyway, and then we attached the map. And then the body says attached is a map showing where your Tesla went on
and
this
those first three are reserved words, email to, and again, it can be a comma-separated list, as many users as you want, subject, and attachment. If you had multiple attachments, it would be twiddly 0, twiddly 1, twiddly 2.
Yep. So then this goes away to FME server and says, please mail me.
That's right, and it uses a different topic there. It uses a topic called Tesla email.
Yeah.
And so somebody's got to be listening to that. If nobody's listening to that, nothing happens.
So there we go. So that's going to be at the end of the day, we'd send an email.
Yeah.
So, yes, we did all this.
We did.
We looked at this. You saw the interface.
Fantastic. Stuart's going to go over it. This is this one here is an example. I have a Tesla simulator. I don't have a Tesla, but I have an iPhone, so I faked it out by having a Tesla simulator. And this is me driving around. You can see my daughter at the bottom there. We got an hour from home, and then she decided she forgot her homework, so I had to go all the way back. Anyway, that was an interesting discussion. Anyway, I drove there in one day. If you're in the Tesla, you would have, I won't look into this, you would have probably, Manning Park, you probably made it around there.
Actually, you can get to Merritt.
You made it to Merritt, okay. Yeah. But you know what they say about Merritt, it's beyond hope. Okay, so there we go. And Craig's always wanted to live in hope. So, okay, enough hope jokes.
Yes. So anyway, that's the example of the kind of map, or more, if we're lucky, this is the kind of map that we'll see get mailed to us. Because this is the route I took that day when I was doing that drive on company time.
Yeah, a good research project.
Yes, that's right. So now we're on to another aspect of this that Don and other Tesla fans want to know when a Tesla is nearby.
Yeah, actually what we really want to know is Dale has a Tesla. We want to know when he's coming near the office, because at SAFE, nobody actually works, except for Dale. And so we're all in the basement playing pool, ping pong, and all those things. So we're having a great time. It's like party central. We get a 5-kilometer warning. We all race to our desks, and then we work. And when Dale comes by, we're just too busy to even look up.
Yeah, actually, since we've done this, it is true that it seems like SAFE staff are hard at work all the time whenever I show up. So anyway, because what they've done is registered on their phones for these alerts. Have any of them fired through yet, Don? He asked nervously.
3 hours ago.
Yeah, that's not a good sign.
Okay.
So anyway, but
we could look at that other workspace.
We
might not be downtown yet.
Right. So anyway, what happens here is we're using this notification service in FME, which allows applications to sign up and allows us to send things directly to Apple phones or else
or Google phones, the GCM,
or the I guess Android phones. Yes.
That's right. So over time, what's happening on the desktop, we've added all these formats, 300 formats. On the server side, it's about protocol. So we're going to continue to add more and more protocols. So if there's a protocol you need to use, then let us know. We'll add it. Like CN, who Stuart talked about, was big on JMS. Okay, I'm going to look. Oh, it's into my hand. I see. And so they needed JMS, so we added support for that. So over time, more and more of these.
And actually, I'll just mention that some folks may be aware of the GeoEvent server of Esri.
Yeah.
We're looking, that has an API to it. So the GeoEvent server could be another protocol that we poke right here.
Yeah.
As, you know, use FME as a gathering point to all the variety of sensors and things we can do, and then send off to GeoEvent server for the last mile.
And you'll see these popping up. Another one is the Amazon Simple Notification Service. So you're going to see more of these.
Yes. Anyway, if you want to know more about these notifications, you can look here at some of these videos and see. But in particular, we're looking at these two apps today and actually the FME Alerts one.
Yeah.
And so when you first sign up on FME Alerts or register, it actually tells the server where you are. And you can tell this thing to kind of keep updating the server or not, so that you can register or basically have your workspaces only alert you if you're nearby to something.
That's right. That's
you
right.
Don't have to,
so now the alerts are driving around, the sensors are driving around. You can start to do interesting interactions between all these things moving around.
So there we go. Look, somebody from the office is phoning me right now. So maybe they just got an alert that I'm nearby.
Maybe.
Yes. Okay. So yes, we are also able to do this on multiple devices. So when we first set this up, we run this workspace. So when somebody initially makes their connection, this workspace here runs.
Yep.
And so let's look at this thing here. So alerts by Tesla proximity.
Yeah. This one's a little more complicated. At the highest level, it looks like it has one transformer. But if you drill in, you'll see that that is more involved.
Right.
But this one transformer, it's a custom transformer. You get it, and it manages all aspects of FME alerts, from the subscribing to the updating to the unsubscribing for any topic. So it's not specific to this particular.
So basically, it will also handle the fact that if you're moving, it'll update this table as well.
That's right.
So the main thing is when we connect with this initially, we end up writing to this table here, which is called the Tesla subscriber.
Yeah.
And so I like to always go and take a peek inside of here to see who we have subscribed to us. So Tesla, we'll pull the location data as well as, the Tesla subscriber. There we go. All right.
You got the other one too. Anyway.
What's that?
You have two tables now.
Do I?
Yeah.
I do want two.
Oh, you want the two? Okay.
Because
so
I can then
see how
tell.
they relate. Okay, gotcha.
All right, so let's go. And now we're going to go out to the cloud. We're going to read down. We'll have the track of where the car is, and then also any phones that are watching us. The thing is, there might be some phones from places like Austin, Texas, down here that are never going to get an alert because they are. But here we go.
Oh.
Right. So we haven't quite got into our zone yet. Is what I would
good.
Take
That's
from
a
this.
good thing.
Yes.
You can see some people are still at the safe office there. That was that other one.
Right. So some people got alerts. Like this is at the beginning.
Yeah.
So if I select this feature here, I can see some things about it, but I can know it's an iPhone and this is its fancy long ID.
Yeah.
And if I go over to where we are now, and there, in a minute or two when we hit this, we should start seeing people get alerts. And I
That's
should
probably a bunch of people, I would guess.
Right. It'd be all of us that are here, really. Whoops. If I get the info on this. No, there's only one. Only one person is signed up, Don. Disappointing. But anyway, we should start to see things happening.
Oh, I just got one.
Yeah.
From FME Meister.
Yeah.
So I'm the only one who signed up.
Yep.
Well.
Is that
okay.
right?
Oh, he got one too.
Okay, well then that's, I'm not sure, I must be selecting things wrong, but I know what we could do. We could hit the table view.
Ah, the good old table view.
Yeah,
okay, there we go.
I don't know what I'm doing.
Yeah. Some people are running update mode. You can see that they're actually running in update mode, so that means they're...
So that's why the table view is handy.
The table view is handy.
Yes.
Yeah.
So
There's no Google phones, though, we can tell you that.
Yeah, no Androids in here.
Yeah.
So anyway, that's good. So some people are getting alerts. So the fake car, the phantom car, is driving by.
That's right.
And so that's the registration. Oh yeah, we should show how the alerts are actually triggered.
Right.
So to do that, I'm going to go and kill this one. Got to be careful here.
Don't kill the wrong one.
Now, this one here is a workspace that is set up to be run every time there's action on the Tesla topic.
Right, so now we have two workspaces, and that's another nice thing about this whole message-based approach, is we have one workspace going to the database, and now we add another workspace that's going to do something different. So we don't have to just build one massive database, one massive workspace that does it all, because there's always a chance we're going to break the existing one, or when we're writing this new one, we would have to shut down the one going to the database. So now we're going to add a second workflow to the Tesla
So
topic.
again, we do the same thing. We flatten the payload that we are given. We get the X and Y. Now, where it gets interesting is this one here, the little-known transformer called the feature reader. Fascinating transformer. Something comes into it. In this case, it's the location of the car. And we can go out to the database and say, are there any subscribers that intersect? Remember, the subscribers are puffed out. And so what comes out of here will be, out of this thing here, all the subscribers which were that intersected our point. And so when we have that, then we go ahead and do some work on that to basically ultimately send them send them a message right here.
That's right. It's a little tricky there, in the sense that we're building the topic based on, if it's an Android device, it's going to be Tesla-Android. If it's an iOS device, we're going to publish the Tesla.
So actually, I just saw mine just said right now, Tesla owned by FME Meister is nearby. So that was put together in here and then sent to the phones, and some of you are seeing that happen live. So anyway, this thing is sitting there running, and every time an update happens where the car is, we do this query, and if we get nothing out, well then nothing happens. If we get 50 out, we do 50. So that's
I
the
just
thing.
got another one.
Yep, the car's really moving through downtown right now.
I tell you, going high speed.
Okay, so that's the alerts, and we did that. So let's just review what's going on. Recap. So the car is being pulled and posting its information to Tesla. One thing runs and stores in the database. Another thing runs every time, and then figures out if we're nearby to a device.
one of our fans.
That's
and if
right.
they are, then they get a message.
That's right. So that's all working. And again, just to highlight, these event-driven workflows work like this. Something pokes the Tesla topic, and then we can keep attaching more and more workspaces that are all small and independent. So, if we want to change what database we're using, it doesn't affect how we're going to send notifications. That sort of thing. All right. All right, now we get into the fun part.
Dale got hungry, and so first of all, he's driving this thing around, so he thought, hey, I wonder if there's any customers nearby. And you might want to take a customer out to a restaurant, or maybe a customer wants to take you to a restaurant, or maybe you want to eat and then go see a customer.
Whatever it is. While we're driving, we can start to integrate points of interest into here. Now, a more practical thing would be, where can I recharge the car? And we could do things like, say, if the battery is getting less than 40%, then let's take a look and start telling you, we could do, that would be a more practical, but this is more fun.
In the hotel in Toronto, they had a charging station. But it took a Visa.
Oh, really?
Yeah.
Wow.
So,
Okay. So anyway, we're going to try to set this up so that we're going to add the concept of points of interest into here. And then when we're near points of interest, we're going to do things.
Yeah.
So first we've got to load those points of interest.
That's right. That's right. And
Now,
I want you to, oh, wow. Yeah, but our customers are in the Salesforce database.
Which is Salesforce, if you don't know, is a CRM, a customer relationship management system that's in the cloud.
Yep.
Very popular, widely used. We do use it in FME, and it's in the cloud. But the problem is, Don, how are we going to read that thing?
That's right. And before 2013, you couldn't.
Right.
Yeah,
so we added in 2013 the concept
bubble.
of cloud as a new kind of format. So Google Maps Engine is one, Salesforce is one.
That's right.
Actually, the Fusion Tables
Socrata.
is one. Socrata. Some people use that.
Yeah.
So a lot of these different
Yeah.
things that are out there that aren't really on people's
That's right.
desktops.
So that's the second type of cloud we read.
Yeah, as opposed to point cloud,
That's right.
which is a LiDAR thing. We'll get to that too.
Yeah.
Here's our graph of formats. Mark mentioned that we hit 303. I do tell a little side story here.
How many did we add in SP1?
Right. In SP1, we added, I think, 5 or 6 more GPS formats.
And how many of those were XML based?
I don't know.
I think 2.
Okay.
Okay.
But never gave that any thought. But I wanted to just tell a brief story about inventory. If Don and I were running a tire shop, it would be very clear in the fall when we got our inventory. It would be piled up, all these tires back there, and that would be a bad thing. Now we got all our money tied up. We have to pay interest on that, and we don't like that. You know, we want to sell these things. Well, when we're writing software, it's a little bit harder to see the inventory, but the argument goes that the inventory is all the good things the developers have done that you aren't able to use. Now, in the old days, customers used to just download our daily beta builds and have fun. But in the dark days of IT tyranny that people live under today, that is not very common. In fact, very few of you are even using FME 2013. So we can't just rely on the betas as the vehicle for getting the inventory out to you. So we've begun, as of FME 2013, to start to put some of our inventory into our service packs. When we deem that there's no risk and that it's a very safe thing, we can, particularly adding formats is a very safe thing. So we put more stuff into SP1 than we ever have before. So there was a lot of changes, a lot of good things, and actually SP2 will similarly have a bunch of things in it. But by the time we get, SP2 is like June-ish. By the time we get to SP3 would be the fall, then I'm going to say, you know what, the inventory, I don't mind.
No, that's right. It only has 3 months to go.
It's expensive for us to be putting stuff into SP2 and FME 2014. So we have to weigh these things. So by the time the fall comes around, we'll just say, too bad, you're going to have to wait till January if you can't take a beta. So that's a bit of a change in how we work. So anyway, that's our graph. Don, what's your favorite?
Kunta GML.
And because it's named after Kunta Kinte, who was played by Geordie LaForge?
On Roots,
LeVar Burton.
Whenever I read that format, I think about Roots. It's also a funny story there. They sent us this file and said it was GML, but when you look closely, the tags had been renamed to Finish. And so then by...
So you were finished?
Yeah, so that's right. So that meant they were finished. And so then, but it was no problem. We have a very flexible thing, so we added support for that. How about you? What's your favorite?
You know, I would go with Spatial Light.
Okay.
Because I've kind of wanted Spatial Light in FME forever, and it's a handy little lightweight thing. It's got a lot of nice characteristics. That'd be my favorite. My sort of nostalgic favorite is Ingress, because I do believe that as a young lad, on VMS, on a VT220, I think I used Ingress briefly. So it's back, and it's spatial. And so anyway, nice to see that.
And it's open source now, isn't it?
Yep, that's right. So anybody can use it. So Sun Raster is also a nostalgic thing.
And OData is kind of handy for that's another non-spatial format.
My favorite.
You can read Netflix on there.
That's right. All the Netflix title is available by. So you could actually. We could work that into our workflow depending on where you're driving.
We could have picked all movies that had the word Tesla in the title or something.
That's right. That's right. Also, actually, there's on OData, appropriately enough, there's a Nerd Lunches feed.
Exactly.
So you can find out where nerds are having lunch as you're driving, and then maybe stop off, or else avoid the area.
I did.
So anyway,
That's
either
right.
one.
I also like the name OData.
Yeah, that's right. So that's our new formats. But what we wanted to do was say, well, let's add our customers into the loop. And so we're going to read Salesforce. We know we can do that. But here we got a problem.
We need to, they kind of have location, but it has an address, so we need to somehow...
Because Salesforce isn't spatial. Salesforce doesn't actually have a map inside that knows where people are.
That's right.
It knows the address. So we got to convert an address to locations.
We're also going to use my favorite transformer.
We are?
When we load it in.
Okay.
You'll see. I'll point that out.
So we realized we can just use a web service to do this. And so we've been working with a few different vendors to integrate web services.
Why is that one flashing?
Because that's one we actually used.
Okay.
Is that what did you say usually?
It's by the company who they actually wrote Transformer their own
Yes, that's
Yeah.
true. They
So
wrote
they're
their
both
own
true.
plug-in to FME.
Yeah.
But they also gave us a nice license, so thank you, DMTI, for letting us show this on the road everywhere.
Yeah.
We are working actively right now on integrating ArcGIS servers,
Yep.
geocoder, which
Yep.
will also work with ArcGIS Online if you have an account. They
Yep.
have a great geocoder. And same with our friends at Pitney Bowes.
Yep.
Have this thing called the Spectrum geocoder, and we can work with that too. So those
Yeah.
two things are being worked on right now.
Yeah, so really we're continuing what we've done with FME. We've supported all types of data. You know, use whatever data you want, use whatever tools you want. Same thing with web services. Use whatever web services you want, and we're just going to work to provide a way to get access to them.
So here we are. This is Workspace. It's going to read Salesforce.
Yeah.
We're using our test Salesforce accounts, so not all accounts are in here. Just so that you don't think that SAFE is about to go broke based on the small number of returns we get. No, we have more customers than this is going to show. But we're going to fish out only the ones that are in BC.
That's right.
That are in our
That's
sort
right.
of sandbox.
Yeah.
And here we're routing to a number of different transformers, but only one of them is going to be active at a time. So normally it'd be the DMTI one when we actually do this.
Yeah.
And this is where I show a new shortcut. On the right click here, we reorganize this menu, and we also try to put shortcuts to things that we thought people might often use.
Yeah.
So one of my faves is the Control E,
To enable, yeah.
or disable. So E will toggle things.
Yeah.
That's one of my faves. My other one is that we want to encourage you to write documentation like why, the why of the transformer. People can figure out the what it is, but leave behind the why for the poor sucker that comes behind.
Yeah.
And so to do that, you can do K. Control K lets you write why. You too can answer the question why. Okay. So
There we go. And my favorite transformer is on this one.
the geographic buffer?
Yeah, I like that way better than the buffer that ships with FME. Open that puppy.
Yes.
And this is a free one on the store, but it allows you to specify the units. So if you're in lat long, try buffering lat long. It's kind of tough because at the equator it's different than near the pole.
Yeah.
And this one you specify the units, and away you go.
Now this is also showing off a new thing in FME 2013 SP1,
Yeah.
and that is this ability to do to basically compute a value on the fly based on an if-then-else test. And so now here's the story. My good friend, some of you in this audience will know the famous David Van Blankenstein, DVB, as his friends call him.
Yeah.
And David used to live in Vancouver, and in our test database, he's still there. He's in Victoria now.
Yeah.
But David always takes me out for a milkshake. At least when I was younger, I used to partake of milkshakes more often than I do now. But anyway, so what I'd like to say is that, you know, if I'm even remotely close to David, I would probably stop by. But for all the rest of you, I'm sorry.
Well, he's going to buy you a milkshake.
Yeah,
no
exactly.
wonder. Yeah.
Now, if any of you wanted to buy me a milkshake, I could alter this as well. But what we do here is use this new thing called set to conditional value. Listen carefully, because that could come up again.
That's right.
Hint. So set to conditional value. So instead of typing in 250 for everybody, I can pop this up, and then I can write a test that says if the name, and then I can use any of these things, if the name contains EMF.
Which is FME spelled backwards. So that's probably what he did. He changed names.
Yes.
Because it was, people would say, what does EMF stand for? And he'd say it was FME spelled backwards. So the next question is, what does FME stand for? And then by the time we answer that question, they're completely lost.
That's right. So anyway, that's what DVB's company is.
Yeah.
So if the name contains EMF, then I will go 800 meters out of my way.
Yeah.
I'm going to really, really...
You're going to go far. You're almost going to go a kilometer.
It's a long ways.
Yeah.
For the rest
Otherwise,
of you...
it's just 250
yeah,
meters.
I'm sorry. That's all I'm doing. So anyway, but that is a very powerful new thing that lets you often remove some transformers in workspaces and collapse your workflows. So we're going to go a little further for DVB.
And it's not going to, in this case, it's not going to decrease the readability either.
No.
You know, like if you have tester, 4 testers in a row, that's not too readable.
Yeah. So, and then in the end, we just write this into our points of interest table and say that it's a customer, and we put a bunch of other stuff there.
That's right.
So that's that one. It's going to be buffered out.
Yeah.
And
so if somebody wanted to get the geographic buffer, how would they do that?
they would just type it.
Buffer.
You just type geographic buffer,
Or buffer, and then they would
enter.
and then they would hit an arrow, and you hit enter, and it just downloads, and now you too have the geographic buffer.
Yes, that's right. So I won't run this right now because we'll do the next one, and then we'll show the
This
answers.
is already preloaded, right?
It's already. Oh, what I would say is that what we would do if this was operational is I would put this up on our server and have it run every night.
Yes.
Let's say at midnight to refresh the location of the customers.
Yeah.
And that way it would be just scheduled to run and refresh.
Yeah.
Actually, I can run this. What I'll do is I'll redirect this to the inspection application.
Ah, there you go.
And then run this. It'll hit Salesforce first.
Yep.
There it goes. It's reading stuff from Salesforce, stuff's happening. And now we're going to do the geocode. For the demo, we're using Yahoo's geocoder because it's very fast. But the terms of use say we can't store the answers in a database.
Yes.
We're not going to. We're going to just display them.
That's right.
So we're okay. So we can use it.
So you got to read all the fine print very, very carefully.
Google has the same thing.
Yeah.
And here we are. Now the problem is it's all of BC, so the stuff that we want is down here. And we can take a look, and sure enough...
EMF is bigger.
Here's DVB. We puffed them out. If we look at the name, which is down here somewhere, yep. EMF is the big one, and everybody else has nice small little ones. So that's that one. So now we've loaded that in the point of interest table.
Yep.
All right. That's good. Okay, now I'm getting hungry, Don. It is getting close to lunch.
That's right, it is. And so now you want to find a place to eat.
Yes.
And so the City of Vancouver, as we know, they have an open data initiative. They publish a lot of data to an FTP site. So with FME, we all know how to read an FTP file. You just simply download it. If it's zipped, you got to unzip it, and then you can run the workspace.
You know, notice, Don, they have a lot of different formats available. I wonder what tool they're using.
I have no idea.
Yeah, but anyway, if we right-click here, here's an Excel spreadsheet of where the food vendors are, as my son calls them, roachmobiles.
Roachmobiles?
Yeah.
Okay.
And so we can go in here, and let's just add a data set. I'm going to say I'm going to read Excel. There we go. I'm going to paste this in.
And go to the beginning of that?
Yeah.
Yeah. So it's an FTP site.
That's
so that's
right.
new in FME.
So
Now
I
you
just
can
hit
read
OK.
directly from an FTP site.
Bang. And here we go. This is all the sort of roachmobiles that are out there.
Yeah.
And I can then get this. So let's go and make a workspace that would read these things.
I like the fresh bakery one.
Yeah, that would be good. Although I'm off bread right now.
Oh, are you?
Yeah. Oh. So I'd have to pass that one over. But anyway.
We were big into wheat and barley on the East Coast.
Is that right? Yeah, in different forms, I'm told. Okay, so anyway, here's where we read the spreadsheet. And again, this workspace pulls from the FTP site.
Yep.
So I would post this to be run every night. We'll get the locations and then refresh this. And really, it's the same thing. The only other tricky thing I'm doing is filtering out. I don't want the one that say info coming.
Right.
Because if we don't, I want to know what kind of food I'm headed towards.
That's right.
And so that's that. So we would do that. And then here's the workspace that would run every time the Tesla moves. We'll do the same sort of thing and go into our points of interest table and intersect with that.
And you'll notice that this table is this workspace is almost identical to the previous one. The only difference really is the table that's being hit.
And this time, instead of sending a message to the phone, we're going to send an email.
That's right.
We could in the future do an SMS or something else.
That's right.
So this is up there. This one is actually running live. And so with any luck at all, if I look here at our friend the FME Meister, he received emails while we were running that I went by Gnosis,
EMF, imagine that.
in our can, and that I also was near some Asian cuisine, which really would go down well right now.
It would go down really well.
So, you know, it tells me some things here about that.
Yeah.
So anyway, that's that. And I think we're good. Oh, okay.
This is writing to zips.
No, it isn't.
That
this is reading.
okay.
I know, that's
we
what
did
I thought
okay,
too.
we did,
We loaded the food data.
Yeah.
We did all this stuff.
Yeah.
Okay, I think we're pretty much done. Don, I should just check to see if our simulator has finished its run. So that's this one. No,
it's still going.
So,
it's probably on the way back to the safe office now.
Right. So what we're going to do then is ask the question, what happens if Vancouver floods?
Well, you're in an electric car.
Yep.
You know, you got to be. Floods are now even a bigger concern. In a internal combustion engine, you drive into a big puddle of water. It stalls. You get out. An electric car, it could be.
It might not be so good.
It might be electrifying.
So anyway, let's look at this, and here we're going to simulate a drive through, and I'm just going to go ahead and run this.
And you're going to flood Vancouver, I'm
going to flood Vancouver. We're reading from a faked point cloud because YVR doesn't have a point cloud yet on their public site, but we use contour lines to make a fake point cloud.
Yeah.
We're colorizing it with ECW, and then we're laying the Tesla track into that. The key interesting part is over here, where we use this thing here that goes almost like raster math. It does point cloud math, pixel or point by point.
Point by point. So is that new in 2013?
Yes, it is.
Yeah.
And we're using the ability here to do a little test and say if our Z value is less than some threshold, then we're going to tint, basically we're going to knock the red and the green down, and make the blue a bit bluer.
There's something else about this one that excites me.
What is that?
See, Dimitri, we were looking at a map, and I said, hey, it looks great to me, and Dimitri told me I wasn't a cartographer, which is great. So Dimitri was really upset by the maps that I produced, because if you noticed, I didn't worry about if I stuck to the roads or not. And in that workspace,
yes,
Dimitri uses a new feature of FME, the shortest path finder, to make sure, because remember, we're only sampling here, here, here. So, and I was making straight lines. Now Dimitri actually follows the roads of the network, because one of the input data sets there was the roads of Vancouver.
Yes.
So if it's right there.
Yep.
So what he does now in the shortest path finder is you can give it a whole path of points, and each one of those is treated as a from to, and then it snaps to the underlying network. So that's so now with this I could produce really pretty maps.
So you can see there's no cutting the corners here.
No, he's
That's
following the road network, so there's no...
So this incidentally would be what Vancouver would look like if the ocean raises by 15 meters.
Yeah.
So a lot of valuable property would be flooded.
That's right, and Teslas would be, you know...
Probably most of the playing field in BC Place as well.
That's right, and the Canucks.
Yes.
Yeah.
Okay.
So a riot would be more like water polo then.
Yes,
Yeah.
that's right. So anyway, that's a quick point cloud demo.
Yeah.
And now we use this point cloud expression evaluator. This is actually a list of all the new transformers.
My favorites are the JSON ones, and the JSON updater's coming.
Yep.
Yeah.
In SP2.
Yeah.
So anyway, that's the one we used there.
Yeah.
And we did that. But now we get to the end this where, you know, my son is 15 and soon maybe...
I changed this one, report to Dawn, by the way.
Okay, did you?
Because we need to sit down and have a chat,
Yeah, okay.
and you'll see why in a minute.
Okay, I'm a little worried about
I'm
that.
worried about you. You're gonna, you know,
Report
anyway.
to Dawn.
Yeah, yeah. You got to be safer.
So anyway, the idea of this
was a
is
bad pun, I know.
to produce a plot at the end of each day that shows the speed and location and things, and really to highlight some areas of concern that might be worthy of some discussion afterwards.
Yeah, and we'll have a discussion
That's right.
here in a minute.
That's right. But the problem is how to get the great labels. Well, it turns out we integrated this thing in FME called Map Text Labeler. It is an extra cost thing, but it's technology from these guys called Map Text, and it really allows some stunning things to be done.
Yeah. So you'll see in a minute here what Dimitri
So
did.
we won't get in this afternoon. We're going to talk more, but suffice to say, you configure this thing, and we produce a map like this. So I'm going to go ahead.
Yeah.
And thank you, Dimitri, for setting this up.
Dimitri really did some great work here, and you can see again that he got uptight, and the road, the track really does follow the road network.
So I'm going to run this thing. It's again reading all the public data of Vancouver: the streets, the parks, the shoreline,
the transit lines,
and the Tesla track.
Yeah.
One of the things he did here was use the new string functions to glue together a multi-line label that's nicely formatted, padded nicely.
Yeah.
So he's padding it together. It's a multi-line label.
Yeah. He also colored certain text based on attribute values, which we're going to see in a minute.
So we get down into the labeler, which is here, where all these things are coming in, so that it makes sure it doesn't put labels on top of each other. I will show that for the
there it is.
Yeah, there it is. For the Tesla one, if we configure...
Don't leave that one when you're finished talking.
You want to talk some more?
Yeah.
Okay. For the Tesla one, what he did was here, if we go into the style, he said put it into a box. They call these shields.
Yep.
So all the Tesla reports are going to be in this nice white box that won't hit any other labels. So what did you want to say about this page, Don?
I want to next one. Sorry, close that one, but the main one. And the nice thing, too, about the map text labeler is you can specify your target system. So in this case, we're using FME generic, but if you know you're going to ArcGIS, you can pick ArcGIS, AutoCAD, MicroStation, and so on, and then it knows all the font metrics and how they work, and so it can do an even better job. But we're using FME generic because we're just going to look at it in the data inspector.
In our own viewer.
So this is amazing, amazingly powerful.
Yeah. So the other thing Dimitri does after we've done the label is he picks it apart. The multi-liner comes out and he says, was it the street name or the battery? And if that's the case, we're going to make it bold. But here's where the part is interesting.
Here's where Dale gets into trouble.
If the speed...
I'm sure glad your dad's not here.
Yeah, it's just, whoops. Sorry, Dad. Anyway, if the speed is more... Now, Dimitri cranked it down to 40.
Remember, these are in miles per hour.
Yeah. No.
You know where I'm going with this.
Yeah. I don't know. They might be in miles per hour.
They are in miles an hour.
Okay, you're right. I forgot about that.
Yeah.
So actually... yikes, I was...
So I might have to take the car keys.
Actually, I think there's some
I'm going to have to
here.
take the car keys.
So please, Vancouver City Police or
who needs
RCMP...
radar? You just... talk to Tesla.
I'll just ask the RCMP guys to not listen. So anyway, wherever it's greater than 40, we're going to make that red.
Yeah, 40 miles an hour.
He also does something here on the battery level to color that based on the situation as well. So, so basically we can do this kind of post-processing of the label, and it turns out that that is very hard to do, and there aren't very many systems that can do this.
No.
So you can talk to Dimitri afterwards, but this is actually...
This is just a data inspector, so this is amazing what's going on here.
So here we go, and we can see down here that I did open her up a bit on the Granville Street Bridge.
60 miles an hour on the Granville Street Bridge? That's...
I think Dimitri, where's Dimitri? He had some... did you change my speeds?
No, he did not.
A little bit, yeah. To make an artistic thing. I've been framed.
That's right, you've been framed. Your own product used against you.
That's right.
Yeah.
So anyway, you can see the labels downtown and how we're not bumping into ourselves.
Yeah,
the stuff
and how they follow the route. I mean, it's this thing of beauty.
Yeah, and we can follow how we went, and here we are going down Knight Street. And eventually on Knight Street, I think our battery goes, here we go. See, it changed from green to brown here. But all of this nicely labeled. Now, this actually, we had a customer from NASA that gave us a spreadsheet of soil chemical concentrations that they wanted labeled in this kind of a way. And it turned out no other tool could do this.
That's right.
So they wanted a multi-line label in a box, and then when the potassium was over some threshold, then make it whatever color
was
potassium
this of soil samples on Mars?
I don't know.
Okay.
It could have been. Do you know, Dimitri, where was the soil samples? Unknown.
Let's
go with Mars.
Let's go with Mars.
Yes.
Fits back into the theme.
That's right. So anyway, a fun little thing we did there, but very serious implications. We'll talk more about labeling later. So there we go.
That's a report to Don done.
Yeah. And lastly, this is something that Don hasn't seen. We can also write directly to a zip file. So let's take a look at that. And number 10, at the end of each day, this would be something we would schedule to run at the end of each day. We might want to produce a statistical summary. So this, we're going to read the tracks of the day, and we're going to go into the stats calculator here, which has had a revamp. You can do many things at once. We're going to analyze the speed, and we're going to take the summary, the one record that is all of the stats, and I'll put them to a tab called Speed Summary in our Excel spreadsheet, because we love Excel. Then we're going to go, and the guys that are complete, what happens here is that the features pile up, and when the stats are calculated, all of them go out with the stats added to them. So every feature knows the average. So that lets us do something like say, if my speed was greater than the average, we'll go to the faster tab. Otherwise, we go to the slower sheet. So we got those. And then
you seem preoccupied with speed here.
It is something I think of lots. And then the cumulative, if you wanted the running average thus far, is what that's about. We don't care about that here. And then lastly, we're going to output, because we haven't done enough ArcGIS, let's output a file geodatabase.
Perfect.
Okay.
And file geodatabase, as everybody knows, is a directory full of files, right?
Yes.
Yeah.
Not really a file. So anyway.
Right. It's a directory writer.
So what we're going to do is show here that I'm going to use, this is outputting to two things at once. If I put the same zip file in both, I will get one zip file with all these things in them.
So if you have .zips anywhere in the path, it's going to be, everything's going to be zipped up into one zip file.
But wait, there's more. I can actually put a subdirectory in here. So I'm going to say we have a subdirectory called Excel where the speeds will go. And then over here for the file geodatabase, I will add this into, let's say, FGDB. Okay, so I have two subdirectories in my zip. And I will go, oops, I should always make sure that I don't have the things sitting there from before, because otherwise you won't believe me. I may regret deleting that. So
I don't think so.
Let's run this.
Okay.
And it does its thing. And okay, we're done. And so now with luck, if I refresh this, it's back. And if I double click, it's a zip file, and look at that. It has those two subdirectories in there. If I grab the Excel one.
And if your log file was being put in there, you'd also get the log file.
Yes. So some people I know like to put an index.html at the top, make a nice package. Very, very simple to assemble a beautiful zip file with FME now, because we can write directly to zip.
That's right. And FME would be able to read this too.
Yes. So I'm just going to go up to the top here, and I'm going to take a look at the speed thing, just so you don't doubt that we've actually done something. Drag this in, and again, here it comes. I get my 3 tabs across the bottom. These are the faster ones. We can sort them by speed. And the slower ones are here. And then here's the summary of the whole thing. So that's that.
That's awesome.
Don, do we need to send our email?
Let's send our email.
So we'll go out to the server.
And we'll just wait. It's going to run at 2 a.m.
So we got a little bit of time to wait. So let's go here to, whoops, I don't want the jobs, I want this.
Yep.
And I'm going to go here, and number 2, we'll manually trigger this. I'll just say run it right now.
Right, and so this is going to read, whoa.
I was afraid something like that might happen, Don. What do you think that means? What Don and I did, well, Don didn't have anything to do with this. It was me. I've only done this, I guess, this will be my 7th time in 10 days, and I neglected to run the right workspace. So what I was running, futilely, was trying to write the Tesla location to the database. Well, that isn't what I wanted to do. That happens automatically when the Tesla moves. What I wanted to do was generate the 24-hour map. So that was the button I need to push. I need to push this one to run that, and I nervously look at it now. Okay, there it is. It did its 324 things, and now for our final thing, we go over here, and we really hope that the email does come, and there it is. And so, yes, we can see that it worked. Okay. But just in conclusion, I hope you'll agree that you've seen that FME provides a powerful platform for quickly manipulating and transforming data.
Yeah. And for 2013, a big message is obviously web services and cloud. In addition to all the other things we do, this is a whole new world of data sources, but not just data sources, new web services that you can start to leverage with FME. So we picked on Tesla. Of course, we never wrote a single line of code in FME specific to Tesla.
No.
So pick your sensor and have fun.
Yes. And so whether your data is old or new, static or live, CAD or cloud, I hope you'll agree that FME 2013 makes it easy for you to maximize its value. And lastly, thank you so much. Because of this presentation, we're able to write off the entire cost of the Tesla Model S as a business expense. So thank you very much. And with that, enjoy lunch.
Okay, we're going to get going for the rest of this afternoon's presentations. Before we start down that path, there are quite a few zipsters spare on the tables. So if you want to take a second zipster for your collection, please grab one. Within your information packs on the tables there, you got the very handy transformer reference guide, and there will be some spare ones of those as well. So at the end of the day, if you want to take a couple of extras, just certainly go and pick them up from the tables. On the back of the agenda is the feedback form, and we'd really like you to fill that out, please. It will help us for the subsequent world tours that we do. So anything that you can tell us about this, what kind of presentations you'd like to see, please give us that. There's also a card within your pack there for free training. We've moved to complimentary online instructor-led training at Safe Software. So any of the training sessions that are offered online are for free. So you have a promo code here that you can share with any colleagues that you have in your organization. So the Safe Software run online training is free to you and any of your colleagues. And just have a look at that our website and our training schedule to find out when those courses are. So we have desktop introduction to desktop courses, more advanced courses around SQL Server and so on. I think Robin is actually doing a SQL Server course tomorrow. Is that right, Robin? Yep. So please make use of that. Increase your skills with FME. You'll get more value out of the money you've spent on your licensing if you or your colleagues take more training. So with that, I'd like to introduce our first speakers for this afternoon, Steve Bogard and Jonathan McIntyre. And they're going to give us an introduction to some of the work they've done with printing PDF data sets. Thanks.
Good afternoon. Thanks for having us here today. You may notice that we're actually the only unsafe speakers on the agenda today, so they've made sure to sterilize our presentation, and we will hopefully be able to take some of the stuff that Dale and Don talked about earlier and put it into our examples here. We do use Python. Sorry, Don. But there was, when we started the application, it was still 2010, so some of it hasn't quite moved over yet. So just a quick intro. Steve is from Jones Lang LaSalle. He's flown in from Dallas to be with us here. I'm with iOpen Technologies. We're based in Abbotsford. It took me longer to get here than it did him, almost. Even with the new bridge, the traffic just kind of moves, the congestion. So Steve's background is in architecture, and as you'll see, a lot of what we're doing here is mapping floor plans, and so it's polygons in a slightly different context. Who are we? And iOpen Technologies has been around since 2002. As I said, we're based in Abbotsford, and our core focus is really as a systems integrator. We do a lot of CAD to GIS, and more recently a lot of mobile stuff, so we're playing a lot with the JSON readers and writers that Dale and Don were talking about. So Steve's going to take over here for a bit.
Thanks, Jonathan. So real quick, just a little bit about Jones Lang LaSalle, the company that I work for. Jones Lang LaSalle is a real estate services and investment management firm. They specialize in everything from capital planning to property management, facility management, lease administration and transaction management, occupancy planning, move management, really anything and everything related to real estate. Got over 40,000 employees worldwide, operating in about 1,000 different locations across 70 different countries. And most of our clients range anywhere from local area markets, where we were just managing a small portion of their portfolio, up to managing their entire regional or global portfolio. The application we're going to be talking a little bit about today is our OneView Space application. So my role within IT at Jones Lang LaSalle is product management. I'm the product owner for our OneView Space Management application. So that means I'm responsible for overseeing the ongoing development, support, and implementation of that system. And that tool is used in the delivery of a couple of different services at Jones Lang LaSalle. Occupancy planning, which is a part of our business that's focused around helping organizations really optimize the utilization of space within a client's portfolio. And then the move management business, which is all about helping our clients manage the move activity, moving people, moving departments, even moving assets and equipment from one location to another. So we use this system to track a number of key occupancy metrics. We're looking at density of a building in terms of square foot per seat, square foot per person. We're looking at the utilization of space, how much of what percentage of the seats are occupied, what percentage are vacant. We're also looking at the allocation of space to various organizations that occupy the space within those buildings. And we're using it to track all of the move activity as well. So coordinating, actually receiving requests from customers, coordinating with those customers about their upcoming move, coordinating with service providers that are responsible for actually making the move happen. And we have a component within our tool that is focused around mapping. And when we talk about mapping, we're really talking about what's going on inside a building. So we're talking about floor plans, looking at each of the individual spaces within a floor, as opposed to really looking outside to city mapping or world mapping. One of the particular challenges that we've had with the existing mapping technology, which is Map Guide, is the PDF capability within that tool really isn't sufficient enough for our customers and for our users. There are some issues with it in terms of the quality of the image that it produces. And we don't really have a lot of the flexibility that we need in terms of the layout of the information on the page itself. So we reached out to Jonathan and iOpen Technologies to help us solve a particular issue related to PDF printing. And we had a series of requirements for this particular tool. One is it had to be able to integrate with our existing mapping system. So we didn't want to go out and purchase a new mapping system just to fix a particular issue with the printing functionality. We wanted to be able to utilize that, sort of add on additional functionality that was really going to give us the quality that we needed out of the prints. They needed to be able to work with a variety of different data sources. And we'll talk a little bit more about those data sources here in just a minute. Needed to be able to support a number of different browsers. We're primarily an Internet Explorer shop. We also support other browsers like Firefox, but long term, as we provide more support to those other browsers, needed to ensure that any additional functionality that we're adding to the tool can support those browsers as well. Obviously, one of our key requirements was being able to print high-resolution PDFs. PDFs are easy to take and send to other people. We're not always printing the images that are coming out of the system. But we really needed something that was going to be high resolution that could be scaled anywhere from a letter-sized sheet of paper all the way up to, say, a 24 by 36-inch sheet of paper without any noticeable loss in quality. Every one of our clients has different reporting needs, so that means that the system had to be flexible enough to be able to deal with the different types of data that we're going to be overlaying on top of a floor plan. We also needed to improve the legend capability. We'll show some examples of some of the issues that we had with the out-of-the-box legend capability that shows up in the map guide prints. We wanted to be able to take advantage of some of the layering controls that are now available in the PDF viewers, so being able to turn on and off different data elements within a PDF. And then finally, being able to handle some of the complex patterns and labels that we have within our mapping system to display the information directly on the floor plan. Some of the data sources that I mentioned earlier, the foundation of our system is a SQL Server database. So all of the information that is related to the space itself, the organization that's assigned to the space, the room number, the employee sitting in that space is all stored within the SQL database. We need to be able to combine that information with the DWGs and the DWFs, so the actual architectural drawings, the interior exterior walls, the furniture plans. We also needed to be able to tie that to our spatial information, be able to the link between the actual room on the floor plan and the data within that SQL database. And we also needed to have the capability to pull in the different layering definitions for each of the data elements from our existing system. We didn't want to have to replicate those definitions specifically within the PDF function. We wanted to read from the existing mapping system and generate those sort of real time. At the end of the day, we chose that the output would continue to be a PDF. Our existing functionality exported the information out to a PDF, and that's a format that, again, is easily transferred to anybody. But we wanted the flexibility to be able to offer other options at some point in the future, so being able to export perhaps to, say, a JPEG or a PNG file. So just to kind of give you a frame of reference for some of the issues that we were faced with the out-of-the-box printing functionality, so within Map Guide, this is an example of a sample PDF from Map Guide. A few issues here. The legend on the left-hand side is a bit disproportionate to the rest of the drawing. The floor plan itself isn't really maximizing all of the area on the floor. The floor details, which is the text information, you can not really see underneath the floor plan. There is information about the floor, the square footage, the address, and so on. That information is scaled with the drawing, so it's dependent on the size of the drawing. And we didn't have a whole lot of control on the layout of the space itself. Couldn't really control the width and the vertical height of the legend, for example. As you kind of zoom into those different areas within the legend, you can see it's not the clearest image. It's somewhat difficult to read. There are elements within the legend itself that we don't need as well that unfortunately we weren't able to suppress within the PDF function. So, for example, the text themes that show up at the bottom. That text information is directly on the floor plan. It's self-explanatory on the floor plan. We don't need a label there to indicate that was a layer that was turned on in the PDF. So we want to be able to suppress those. On the drawing side, image quality is rather poor. You can see there's a lot of jagged edges. The actual drawing elements themselves are pretty fuzzy. The text is completely unreadable in this example. And there are things that we could do to help improve that. Users could zoom into the floor plan so that they enlarge that area and makes it appear as though the resolution's a bit better, but the reality is our users want to be able to print an entire floor and be able to view any information within that floor plan and not have to sort of stitch multiple copies of the image or the PDF together. So this is what we've ended up with. This is the output of all of the work that Jonathan and his team did. You can see right off the bat the layout of the PDF itself is much better. The legend is comparable in size to the rest of the page. The floor details that you see across the bottom, the text information there, is in a static location. It's the same text height regardless of the image. It's independent of the floor plan itself. So we can print a 100,000 square foot floor plan. That information at the bottom is going to remain the same as, say, a 10,000 square foot floor plan. We've got a PDF example here that we're going to zoom into here. This is an actual copy of the PDF that comes out of the PDF printing function that Jonathan and his team worked on. And you can see the quality of the image itself is far superior to what we have in the old version. The drawing work is all crystal clear. The text information is all crystal clear. It works that way because the drawing itself is actually a vector drawing versus a raster image. So we can scale this up as much as we need to. There's no loss in quality there. The text information is true text within the PDF versus an image. So significant improvements in the quality of the image itself. The information in our legend is now specific to what is included on the floor plan. In this case, we're showing a typical, what we call a space category theme. It's an indication of what the classification of each space is, what type of space it is. And within our space categories, we typically have between 12 and 15 different attributes or different categories of space. In this example, you're only seeing about 7 of them. That's simply because the PDF function is smart enough to know which space categories existed on that particular floor and has restricted the legend to only those 7 or so values. So it is all specific to what you print. If I zoom into an area where I only have 2 or 3 space categories, then the legend's only going to show that as well. It's also a much clearer image on the legend. It's all built dynamically through the PDF process. One of the other requirements I mentioned earlier was the ability to take advantage of the layering controls within the PDF viewers. So being able to, for example, turn on and off different data elements. You might want to turn on the furniture plan. You might want to be able to turn off some of the text themes. I can see that a little bit better. So what it's done, what the script has done is take all of the individual layers that we had within the map guide tool and transferred those over as layers within the PDF file. So what John and his team have really done is captured all of the requirements that we identified and then some. Jonathan's going to talk a lot about some of the additional features that they incorporated as they developed this functionality. So I'll hand it over to Jonathan to really go through more of the technical details of FME Server.
All right, so as was mentioned earlier, one of the challenges with writing PDFs is that there isn't a simple way to do it. And we started off with a kind of prototype example back in 2010 when FME Server was just getting its footing, and we've continued to move forward with it over that time. And you'll see that as we go through this, there is some information that's, or some of the workspaces and transformers kind of deal with some of those inherent issues that we crashed into. So why did we choose FME Server? Well, we reviewed all the other options out there, and we did a fairly extensive review, and nothing else stood out. The key thing was the ability to print vector data. Everything else was throwing out raster information. One of the other issues that was important was that we needed to be able to offload the processing from the mapping servers, so we can just link to it, and thereby allowing it to be both scalable and stable. As an organization, we had quite an extensive FME background, and JLL already used quite a number of automated or batch processed FME scripts to deal with the data. And as Steve mentioned, the ability to do new and cool things going forward. So outputting to different attribute formats. We'll have a look a little bit later at some different ways of calling it. And then, of course, as PDF has developed, we now have the ability to add attributes within the PDF itself. So it becomes almost a self-contained database. And you'll see I didn't quite achieve 10 transformers or less. In fact, I'm nowhere close. And you can kind of see the green highlights the custom transformers. So, well, we're well over several hundred different transformers in there. And as we move through, it's kind of organized from left to right. So we start off with the source data. So although we're pulling this from a map guide site, we're actually reading the source CAD files to generate the data. One of the key features we were able to add was the ability to rotate. So we transform the data on the fly so that the users can take odd-shaped floor plans and rotate them. Steve mentioned the themes. So themes include the colors, patterns, and text. And then the layout. And this is, PDF layouting is a challenge. It takes some getting used to, just because it has some particular requirements. And then ultimately the output to the PDF. So the key components based on what we went through here were FME server as a whole. So that we use the data streaming option, meaning the user clicks the button and waits, and eventually the PDF just shows up in their browser. The PDF layout was really important, being able to configure where the parts go and dealing with how they are structured. It had to be configurable, so the user has to be able to drive the output based on information that they control. Text labeling was a huge issue. They were talking about map text. There is no current map text output for PDF, and you'll see as we dig into some of the PDF text labels, it becomes quite complex. The high resolution print and legend, it just has to be there, and it has to be of a quality that it doesn't matter how far you zoom in or how large you print it, although we just generally, to keep it simple, allow the users to, or recommend they print it at 8.5 by 11 for the PDF. They can send it to any document output tool. Polygon themes. So Autodesk has a wide variety of very complex patterns. PDF and writing those becomes challenging. It's just difficult to replicate those easily. And then finally, the layer control. So the data streaming service, in our case, is executed by choosing Generate PDF. The users also have the ability or the option to download it as a zip file. Most of them prefer not to use that. You can see that there's a number of different parameters that they control. the number of parameters that you'll see here is what gets passed from the JavaScript over to the FME server. There's actually, within the main workspace, over 125 different user configurable parameters. It gets complex, and so we want to make sure that we have the flexibility, but we don't, the user doesn't need to see it. So the layout. In this case, a really nice square floor, nice square building, but it doesn't always turn out that way. There's a lot of strangely shaped buildings, and we need to be able to take that and fit it within the context of the page itself. You can see along the top there's a map title, left-hand side is the legend, there's scale bar, and the map or floor plan details. We have to be able to deal with all kinds of different shapes, make them fit in there, and for example, the triangle, the user may only want part of it. So we have to scale, offset, and move that around within the context of the page layout, and without overwriting the other parts. Obviously, the core or center of the floor layout is the most important, and so that has to be always taken care of first. So the PDF layouter is really our custom transformer to take all the different parts and start pulling them into place. You'll see that we do end up with a Python caller here, but essentially we determine the rectangle, we offset it, and then we place the different locations. So within here, we write the legend, we write the title, and then we deal with the themes to output. As Steve mentioned, the legend itself wasn't quite giving them the output they required. You can see that these two values were from the same floor. As he mentioned, this is context, or this part is context sensitive. So we're only seeing what is turned on in the web mapping application. So from the user perspective, they're just using the tool they've always used, but when they go to output it, we add some additional intelligence. Again, adding the full floor plan here. And we also have the ability to do multiple themes. So certain themes are patterned, and so they want to be able to overlay them on top of colored themes. And I think the next one. So within the legend, we start building a custom transformer, and using Python, we separate the values out to generate a primary name, and then which is the layer name, and a secondary name, which is derived from the database. All right, so text labeling. This is the web mapping application. This is what we're trying to replicate. If you're used to dealing with text within FME, it doesn't have a justification. And so we need to be able to take what's on the left and move it over. So we spent a fair amount of time working on the justification, and fortunately the SAFE team came up with, the SAFE support team came up with a very helpful tool, and we end up stroking the text and then writing it out, calculating the length, and then restroking it. Now that may sound sexy, but it really isn't as fun as it seems. But it does give us the eventual look we're looking for. Now, we also have to always keep the text horizontal. So no matter what rotation we turn the building to, the text always has to be horizontal for the users. This created some interesting challenges with donuts and holes, and just making sure that the space showed up. Because we also allow the user to clip, so you can see on the left-hand side there, when they clip the image, we need to then determine a minimum area that we label. So we want to make sure that if they clip it and it's larger or large enough to fit the label, that we do. For the smaller rooms that aren't clipped, we still allow them to generate the text. They also have a bunch of custom symbols depending on the client, so things like phones and locks and keys and different stuff like that. So we're running in through custom font libraries and making sure that those show up in the correct location. Oops. So essentially in here, the key thing is that depending on what happens with the floor plan and some of the new 2013 Service Pack 1 transformers I can see are already going to help me improve some of these testers with the if then else's. But we need to deal with the holes within the donuts, and so depending on what the output is, we either use a center point or inside point placer to get the text in the right location. Once the text is there, we join it up to the database and then deal with the offsets. So within the mapping application, the web-based tool, a new line character in the database easily maps out multi-line text. In our case, we can't use a new line character. It's not recognized. So we have to use a list, explode the list, and then actually multi-line text based on that. And it started off as, okay, we'll deal with it. And then as we started dealing with some of the clients, we ended up finding that they actually, for some of the larger rooms, have 50 different employees in there. So we had to come up with a way that didn't care how many employees and just would allow it to run through the label. And then we justify it. So as indicated, we explode the text, and then we do a stroker, geometry replacer, or text stroker, and then basically end up with the center justification and create the label. So configurability, we had to be able to take the legend in the web mapping application and allow the user to control the output to the PDF. So you can see here, again, this is the user interface for them, and we just take the parameters that they pass, again, 125 plus. It's parameters, parameters, parameters. It just goes on and on, and they're all driven by different values. So if the legend is turned on, then it partially enables the transformer, and then it will pick the particular table it needs to join to and move on. So you can see some of the custom transformers that we built to try and cope with some of the complexity, stripping it out so that that large main workspace isn't as complex. And again, it all runs through. You can see the different themes there. So next up is the polygon theming. So we're dealing with things like zigzags, waves, honeycombs, bricks, all kinds of different looking patterns, and we have to make sure that we replicate them as closely as we can to the web mapping application. Now, it doesn't always work out perfectly, but it is generally very close. So again, in order to generate the patterns, we end up having to use Python scripts, and you can see that we're actually looping through and adding coordinates to draw our zigzag lines or whatever it is we're drawing. One of the features that kind of came about totally by accident was the ability to dynamically theme the data. So the way the users had to deal with the theming before was go through a particular theme tool. Now they can just enable the theme mapping and have it show up dynamically on the screen. So as they click it, as they choose the values here, those values are reflected and they're pushed through to the PDF. So it, as I was talking with Steve about this, actually we're thinking about stripping it out to become its own functionality because the users are finding it so helpful. Sorry. The patterning, so depending on what exactly is happening, we're either patterning it, symbolizing it, or hatching it and running it through the different custom transformers. And here we're dealing with just running the values in to get the hatch pattern. So we have to, because they are two totally independent sets of data, the legend and the floor plan have to be patterned and themed individually. So we end up with a accurate representation in a vector format. So as mentioned, the layer output in the web mapping application gets driven through for certain outputs in the PDF. The layer names are controlled statically, but for other ones, we drive them dynamically from the database. So as Steve showed you in the PDF there, you have the total control over the output. Now, one of the things we found as we went through this was that although for the most part the labels and names and databases were standardized, there was always one or two per client that seemed to just defy the rules. So we ended up creating an array out of the values and then building an array of the array. So we end up with a within the JavaScript actually passing a potential name through so that we can catch any variability. And then I'm not going to pop into the PDF because we're out of time. So I wanted to just open it up now for any questions you might have, and if you have any.
Yeah, it was just on your clipping there. It was interesting. One of the images you actually had clipped the text. So every text character has been written out separately, or
no, that was actually just a screen cap. Yeah, what we calculate the minimum area of the clipped polygons, and then we'll actually label them. So, yeah.
Any other questions for Steve or Jonathan? Well, thank you very much.
Okay, yeah, so I'm going to talk about FME Server for the next 20 minutes or so. So just a quick show of hands, who actually has used FME Server or has FME Server installed? Just a quick show of hands, give me an idea. Okay, so a few of you. Okay, so what I'm going to do is give you a brief introduction as to what FME Server actually is for those that haven't used it before, and then we're going to have a look at some of the functionality that's new in the product this year. First things first, I want to introduce you to a new product we have called FME in the Cloud. So this is, it's not yet out, but it's coming up very soon. You can go to the website and register. But this essentially enables you to run FME Server that you currently have to download, install locally on your local server. You can log into a website and launch as many FME servers as you want, and we manage and maintain the FME server. So it's a big, big shift away from how you've been working with FME Server before, because you've had to, apply patches, look after the backups. If the server crashes, you have to look after it. And, you have to invest in the hardware as well. So it's a big commitment for your organization to buy FME Server. They're going to have to, you have to basically hire someone to look after it. You also have to have the hardware. So hopefully this is going to dramatically lower the barriers for you to be able to get started with FME Server, launch as many FME servers as you want. That's the other key difference right there is it's going to be on-demand pricing. So rather than paying up front for FME Server, you can basically rent the FME Server on an hourly basis. So you'll pay for each FME Server that you launch in the cloud. So we're really excited about this. We think it's going to lower the barriers of entry, so you can get into our enterprise technology easier. And we think it's also going to offer huge value in terms of saving you costs and working with the service. So I'm just going to show you a quick demo. Okay, it really does like to jump back to VGA mode, but that's fine. So you can see, this is the website here. You can go to fmecloud.com, so this goes for everyone online as well. And you can see you can just enter your email here to get on the beta list. And we'll actually email you, once we're starting to roll this out to the general public. You can't actually log in or sign up yet. But what I want to show you is launching an FME server. So I am actually logged in here. And so these are all of the instances I've launched throughout the World Tour. You can see I have one instance running here already. So what we're going to do is launch an instance now during the presentation. So I should be able to go new instance. Let's call it Vancouver. WT. So this could be, a use case here. We already use this internally. Staging, production, development. 3 separate servers, 1 for each environment. We have West Coast, East Coast, and Central servers running on our other account. You can choose the instance type here, so medium and large. This is the size of the machine that will actually start up when you launch. So the medium instance comes with 2 FME engines on it, and the large with 4 FME engines. This is all very early days, so things may change, but we want basically this to be as flexible as we can for you. So I click Launch Instance now, and you can see now that instance is provisioning, and so it takes about 9 minutes to launch the FME server, and then once the FME server is launched, you never have to do this again. You just do it once for each FME server, and then you have a fully working FME server. And as you can see there, you can terminate an instance whenever you want as well. So, say you had a processing job you wanted to do, and you have a huge amount of data you want to process, you could bring up an FME server in the cloud, you could run it for 24 hours, do your work, and then shut down the FME instance running. The other thing is we have a PostGIS database for you up there as well, so you can load your data into that local database. Okay. A lot of the questions around the cloud I mainly got when I was on the road was to do with security. Oh, our organization can't use this. We're worried about security. But from my perspective, obviously, you're going to centralize everything with us. So we're going to make sure that service is secure to as best our efforts. But we're leveraging Amazon's architecture. Amazon have hired hundreds of the best people in the world to work on security. So, we're going to leverage their technology. I personally think Amazon's security is a lot better than security at Safe, just because, they've got the top people in the world working on it. So, that's maybe still a concern for you, but you can discuss that with us if you do have any, worries about that. But from our perspective, it's a safe thing. The other thing is with the cloud is, if you have an FME server locally that you want to open up to the public, well, you're going to still have to open a tunnel up, into your organization to let people access that FME server. By putting that in the cloud, what you actually do is say, okay, we're going to put the FME server here in the cloud, and then rather than having to come in through your organization and open a tunnel up, you can just let people connect to AWS. So from some aspects, it's almost more secure than having it internally as well. Anyway, okay, so let's talk about what FME Server actually is for those that are not familiar with the product. So FME Server is our enterprise product. It's a scalable platform that basically allows you to do flexible data transformation tasks and loading services. So FME Server uses exactly the same technology as desktop. So all those workspaces you've built, these hugely complicated PDF generation workspaces you've built, you can put those on the cloud and onto FME Server locally as well. There's no change in workflows here. What we essentially do is currently you're probably doing something like this. This is Don's infamous slide from many years ago, but it's still relevant. You're running at the moment, probably in your organization, FME desktop locally. So you've built your workspaces, you've committed the time, and you're running the workspaces locally. That's fine, that has good value. But the first thing you can do is take those workspaces and push them up to FME Server. So number one, we're centralizing everything. So often with an FME Server, it's on a bigger machine, a more powerful machine. So the first thing is your workspaces are likely going to run faster. The second thing with centralizing is there's a lot of tools on FME Server that help you manage your workspaces. So there's log files that are interactive so you can see if a job's failed or succeeded. There's scheduling, so you can schedule a workspace to run every day, every minute, every week. It's completely flexible. There's also job queuing. So on FME Server, we have this concept of FME engines. For each FME engine you can have as many as you want. You can run FME processes concurrently. So if you had 10 engines, it would be like having 10 desktops all running at the same time. So what you can do is schedule 100 jobs to all run at once. They'll be sent to FME Server. All of the queuing manages the jobs and assigns them to FME engines when they become available. So it's much better for dealing with like high load scenarios and any scenario where you want to basically scale over multiple engines as well. So that's kind of centralizing your data transformation. The next thing you can do is create services out of those workspaces. So this is a huge value of FME Server. Let's take a scenario. You have a database, a corporate database, with all of your data in that database. Could be Oracle, could be SQL Server, it doesn't matter. So what you want to do is allow the end user to basically extract data out of that database in a certain format, in a certain projection, in a certain area. So in FME Desktop, if we just had that, the user would have to start FME Desktop, maybe use prompt and run, and they'd kind of have to be a GIS expert. They'd need to know where to click, and they would open Desktop locally, click Run, and choose, shape and NAD83 or whatever you want, and the data will be downloaded locally. So that's okay, but they still need a license there. They still need to use FME Desktop, and they kind of need to know what they're doing in there as well. You need to know your way around. So let's take that same workflow and we register it with it's called a data download service. It's data distribution service with FME Server. So the end workflow this time is, rather than the user having to know FME Desktop, it's just a web page. So they go to a web page, they say, oh, okay, I want the data in shape, I want the data in Texas State Plain, and I want the data for this area. Click order, and then they get the data emailed to them. So you can see there, that's a service. We've built a web service, and we've wrapped the workspace around that. And it makes it much easier. You don't have to code anything to enable that workflow. That's built into the product. So let's see what other services come with the product. So that's kind of the data distribution service. The data streaming service is very similar. The data streaming service essentially, rather than the user downloading the data, so data in a corporate database, you want the user to basically stream the data out. So let's say you have Google Maps and you want to put data on top. you would use the data streaming service. Google Earth, and you want to overlay data, you'd stream the data. So it's a good way to create an endpoint out of your corporate database or your disparate data sets so that you can overlay or mash data up into other applications, stream the data. Upload and validation, we saw that this morning with SynCAD. So this is a way for basically through a web page people can upload the data that they want to have QA'd, and you can have any QA workspace on the back end that you've built in the workspace, any business rules that you want. So the file's uploaded, the workspace runs, and then it sends the user back a report or whatever you want saying this has failed, or if it's successful you can load it in. So centralization, we talked about notification service. So we'll talk a little bit about this in a minute, but this is what you saw with Don and Dale this morning, processing all the real-time events with CN this morning as well. Really, FME Server has dramatically expanded in scope, and it's much, much more powerful this year. So let's take a look now. I've explained a bit, hopefully, what FME Server is. What's new in FME Server 2013? So the first thing is a completely new web interface. So I won't go into too much detail here, but for those that had FME Server previously, the main thing is previously we had a user area and an admin area, and we made the decisions about what went in each. So we said, oh, scheduling is an admin task. We're going to put that in the admin area. Configuring notifications is an admin task. We're going to put that in that area. But really, who are we to make that decision? So what we've done now is we have one area where you log in now, single sign-on, and it's all permissions-based. So the admin can say, well, Stuart can set notifications and schedules, but Steve, my teammate, he can log in with his user details, but he's not allowed to see anything. He can just run workspaces. So that's the main difference there. It's all on a nice HTML5 framework now as well, so it's a much nicer end-user experience with drag and drop and things like that. So that's a huge improvement for both you as a GIS user and for the end user as well, actually. The other thing is single sign-on's been added this time round for SP2, I believe. So we had single sign-on last year, but now with FME Server 2013 SP2, what you can actually do is it has pass-through authentication. So let's say you configure Active Directory with FME Server, which basically means if you are within your Windows login and you try access FME Server, what happens is FME Server takes your credentials and it will auto-log you in if you're right and if the permissions are good. So you don't even have to enter any username or password, which was a user-driven feature, basically. People were after that. So yeah, Active Directory support, again, for Active Directory you can configure at the group level, so you can say this group of people have access to these things, this group of people have access to these things. It just makes it a lot easier, otherwise you have to manage your Active Directory users and your FME Server users, which is a little bit more work. Okay, so let's talk about the notification service again. So Don and Dale touched on this morning. So there's a lot of buzz around the notification service. You know, it's the latest thing in the product. There's a lot of power there. There's a lot of different cool demos flying around. What I want to try and do is kind of try and address and apply the notification service to a more traditional workflow. So a workflow that you guys can relate to, hopefully. And because I think notification service, we do call it that, but it's a lot more powerful than that. You'll see with the protocols in a minute. It's really a different way of interacting with FME Server. And we think it's really, really powerful. So we have this diagram here. We have the sending applications on the left. That could be something like an email application or something like that. We have the publications with all the protocols on. And so you send an email in. The email forwards a request to a topic. The topic has an FME Server, FME Workspace listening. The FME Workspace takes in the data that was emailed in, runs the workspace, and then you can send notifications out. So you're going to see this is it's like a big jigsaw piece, and you can plug everything together to achieve what you want, hopefully. So let's have a look at a nice simple scenario, data transformation by email. So you're out in the field and you're doing some surveying, you're collecting some data. You collect your data and we make it easy for you. We don't want to make you go to a web page and upload. We just give you an email address. Just email the data at this email address. So you attach your CAD data to the email, and then you email that file to the address we gave you, which is actually, it's sending the email straight to FME server. This is no code here. This is all out of the box. FME server takes the email, strips the contents of the email out, it strips any data off the email, and it passes it to the Workspace. The Workspace then runs, processes the data, and then it sends whatever it wants out back. So you could send an SMS, you could send another email, you could stream data somewhere, you could upload data to an FTP. So you can see there's a huge amount of flexibility there. It's quite a traditional workflow, and you probably would have done this through a web form before, but we want to make it easier for you to get data into FME server. Just as they did 20 years almost ago, 15 years ago in FME, they did this by adding more and more formats. We want to do the same for FME server, but with protocols. Okay, so let's give you a quick demo here. Okay, apologies for the resolution here, let's have a look. Okay, so we have this simple demo here, and what we have done is we're going to do the last scenario. So we're out in the field, and we have been surveying, and we have got our data set now. So we're going to try email the data to FME server. And, okay, so I'm going to email this file to FME server. So this email address here was created by FME server, cad_waterqa@demo.fmeserver.com. I'm going to send this file at FME server. So FME server's going to take that file in, pass the CAD file to a Workspace, and we're going to perform QA on that file. So we're going to check for if we're surveying pipes here, sorry I forgot to say. So we've surveyed some pipes, and we have business rule. The pipe must have a diameter value on it. So I don't want it in the Oracle database unless it's got a diameter attribute on it. I don't want any bad geometry in that Oracle database either, so I'm checking for self-intersection geometry and things like that. So we can see here this translation's failed. Okay, so let's see why. So we use the XML templater in this Workspace to actually produce a little report here. And so we can see it actually tells us, you know, this feature here had invalid diameter on it. We're using the Google Static Maps API to produce these images. And if we scroll down, you can see here invalid geometry. So if I scroll across here, can you see this one has self-intersecting geometry? So we've no code here, all in FME. This has all been done in FME here, including sending the email back. Okay, so we've gone back out in the field. We've got instant feedback as to what's wrong with the data. So now I can go here, and this time I'm going to try good data. So data v2. I'm going to attach the file, and the good one, I've got to get the right one. Okay, so this time what we're going to do, the data should pass, so we're actually going to load it into Oracle. So if we come to this map here and watch, so this time the data's going to pass, it's going to load into Oracle, and what we've done is hooked Oracle up using FME server via WebSockets to the browser. So you can see as soon as that data gets loaded into Oracle, basically what we have is we have a trigger set up on Oracle, and Oracle basically takes all the data that's coming in, gives it to FME server, and then FME server streams it to the browser using WebSockets. So we did cheat a little bit on this one. We used another piece of technology called Pusher, which plugs into FME server. But next year, we will have WebSockets. Probably not allowed to say this, but I'm going to anyway. We're going to have WebSockets in 2014. So we'll be able to do this without any code or without any other services, which we're really excited about. It's kind of like the next generation of data streaming. You saw how fast it was, 388 features in a second, and that was the actual data I emailed at FME server. Okay, so I just want to quickly talk you through the workflow of what we did there. So the sending application was Gmail. I sent an email with the CAD data onto the topic. The topic had an FME server Workspace listening. The Workspace ran the translation. In the first instance, it failed, so I sent an email back to the receiving application, which was Gmail. I could have sent a Google push. I could have sent a JMS Java message stream. I could have sent an Apple push. You see how I can plug everything together here? Completely flexible. The second workflow, I sent an email with CAD data on. It went to the topic. This time it got loaded into Oracle somewhere else. So then what happened is Oracle actually became the sending application. I had a trigger in Oracle and I sent HTTP post. I pushed the data to FME server. FME server then took the data and let's say it sent the data out via WebSockets to the receiving application, which was Google Chrome. So we can get pretty powerful here by plugging all these things together. And just with formats with FME, these are just going to increase. We're going to support more and more of these protocols. And with all those sensors out there, it's going to be a great way to interact with your data. Okay, a quick note about the FME server migration strategy. So for those of you that have tried to do an upgrade of FME server before, apologies for that, but we've made it much better now. Basically before what you had to do was a lot of manual steps. Even if you wanted to move from 2012 SP1 to 2012 SP3, we didn't bring anything across, we just brought the workspaces basically. Now I'm excited to announce from 2013 going forward, it's very, very easy for you to do a migration. So if you migrate from SP1 to SP2, we bring across the repositories, security, notifications, all of the services, all of the schedules. So anything you configure in the web interface comes across. We're going to be using this for our own cloud stuff, so it's going to be heavily tested and it works really well. Okay, so let's get back to the cloud. Did we manage to launch an FME server in less than 10 minutes? It should have taken 9 minutes. Let's have a look. This is the moment of truth. Okay, so there we see now, Vancouver WT is running. I can go here. And you can see the URL, hopefully, Vancouver WT, which is the server name, Stuart-Harper, which is my account name, and then just the generic FME Cloud URL. So, apologies, the internet's a bit slow here, but here we go. Here's our FME server. So what's our login? Well, obviously, we don't want to do the traditional admin username password. So what we do is we allow you to download the credentials once for that server. So you can download the credentials, and you can see here there's a big long hash password. We don't even store this on the server. It's only, basically it's gone now. So we can log in, and we should, when we log in, see that we have a 2-engine FME server running, and it's ready for you to go. You can now upload workspaces to this server. You can start sending and receiving notifications. The email, all the email stuff's configured for you. And you're going to pay per usage. And so let's say, okay, I've had enough, I've done my work, simply click terminate, and then you'll stop being billed for this, and that's the end. Okay, so yeah, that's kind of an introduction to the FME Cloud. The other thing we've actually been working on is logging in the web browser as well, so I think I've got time to quickly show you this. But obviously, we need to let you have out the log files, and at the moment, they're all on the server. So what we've done is, it's actually an open source product we're using, but if you can see here, you can select these. If I can select these tiny. I can select all of the log files, basically, and then what should happen when I come here, so if I refresh this page here, you can see any interaction in the FME server in any of the log files is actually streamed to this page. So I can go here, and let's try run a job here. Let's run this one. Doesn't matter if it fails. But we can go in here, and you can see the translation being run, and you can see the translation being run there. And you can also see any errors. And it's really good because you can select all the log files. You could just do something like send one notification, and then rather than having to look through all the log files, you just come in here and say, oh, it's in this log file, and it shows up in the stream. So this at the moment is only for FME Cloud, but who knows what might happen next year in FME Server 2014, so watch this space. Okay, so a lot to take in there. I just want to say we do an FME Server monthly webinar. My colleague Steve does it every month. It's a 1-hour deep dive, completely free. We'll take you into a little bit more detail on FME Server. So if anyone has any more interest, then I'd strongly suggest that you attend that monthly webinar. Does anyone have any questions? Okay, so yeah, our FME cloud is built on top of AWS, which is Amazon's Amazon Web Services. So at the moment, the servers are in America, but what we plan on doing is when you launch that server, you'll be able to choose a region. And so any Amazon region, you will be able to choose. I think there's one in Europe, a couple in America, Asia. I don't think Canada has one yet, but obviously we're going to let Amazon build that architecture, so I'm sure they'll have one in time.
Yeah, so a couple more lightning talks, and I'm just going to walk through one of the new transformation tools that have been added to FME 2013, which is the geometry validator. It combines some of the functionality that quite a few of the other transformers have in FME, the OGC geometry validator, the self-intersector, and some of the other 3D validation tools that we have. Part of the motivation for this work was to consolidate a whole bunch of transformers. That's always a nice thing, so that there's fewer transformers in your workspaces. But another one was that some of the existing validation tools that we had in FME actually always changed your data. So like a self-intersector, when you wanted to check for geometries that had self-intersection, it actually cleaned up the self-intersection at the same time. And there were some, I guess there still are, some users who really just want to do a QA on the data and they don't want the data to change. And so that was part of the motivation here, was to sort of change some of those tests so that you could choose whether you just tested for valid geometries or actually repaired them as well. So that's some of the work that we do. And then, of course, what we needed to do is to report out a little better what was wrong with the geometries that you might be validating. So the geometry, did you steal my little pointy device there?
I didn't steal it.
So the geometry validator has an option at the bottom there. Do you want to repair your geometry, or do you want to just test to validate it? If you just choose to validate the geometry, there's 3 output ports, and you'll only get data coming out of 2 of those ports, which is passed. Yeah, that was a good piece of geometry you had there. Failed, and no, it failed the detection. If you choose to repair the geometry, then you potentially get output from all 3 ports on this transformer. The passed, yeah, was a good geometry. It failed to repair, so we don't promise to be able to repair every kind of geometry. And if it was repaired, it comes out the fully repaired option. And then we have some various levels of issue reporting in here to tell you where some of these errors potentially occurred. So this is kind of a classic case of some self-intersection geometries, 2 intersections here and here. If you ask to repair or validate this, you'll get a few attributes thrown up onto the feature which describes where the first of the bad occurrences of the geometry occurred, and the kind of error that FME detected. We also use a thing called geometry traits, which are like attributes thrown onto individual geometries, and that's where all the gory details of the detailed errors of the failed geometry are. And so in this case here, we've picked out on one of the geometries that we fixed that it's a self-intersection, the location X and Y is this, and so on. One of the interesting things we did discover here is, as we're testing these geometry validation tools, is that different databases behave in very different ways in the way they see a bad geometry. And of course, some databases do clean up the data. So an example would be this case here. I forget which way around it is. Iris, who is here at the back, has done a lot of the testing on this tool for us. And so what we found is that, say, in Oracle, if you had a self-intersecting area like this, once you repair it, Oracle likes this area to be not a donut, but that these areas are actually part of the outside world, and it's just an area. Whereas Esri, if you threw that into an Esri product, these would become holes within a donut kind of polygon. So different databases actually view different quirks of the geometry in quite different ways. So far we've added 12 tests to the geometry validator, and we're going to be adding more. We're testing for things like not a valid number for a geometry, null geometries on different geometry parts in the geometry that you're throwing at, duplicate points, self-intersections, 3D surfaces missing vertex normals. If you ever miss any of those, you'll know that you can catch them. And then the OGC simple and valid tests are in there. So just having a look at some of the tests that FME can run for you and how those are reported back to you. We can have a look at a simple workspace here. And we're just reading in some parcel information, filtering it by geometry, trying to build some areas, and then throwing that through the geometry validator. And in this case, we're asking it to repair the geometry. So we could just give that a quick run and see what the results look like. It'll pop up into the new data inspector. We've got a couple of here geometries that we did repair. If we zoom in on one of those, we can see that it's got some sort of a spike down here, and if I click on that, we get all the details here on that feature telling us that it was a self-intersection. So those attributes are the summary of what went wrong on that geometry, and down here a little bit, if we poke around a little bit more, we can see that there are some geometry traits here that give us a little bit more detail as to what would be wrong with that geometry. And if there were multiple errors on that geometry, you'd get multiple geometry traits in here. Let's have another look at a slightly different example. And what we can use here, it's kind of difficult sometimes to look at those geometry traits if you're not using the data inspector tool. So we have a geometry property extractor tool in FME where you can choose to move traits up to attributes in FME. So if you do want to have a look at the detailed reporting from the geometry validator, you can do that as well. It's sometimes important to sequence the tests that you're running in your geometry validation, so you can pick on tests and move them up or down. If I can, actually, there we go. So we can make a check for null geometry parts before we check for invalid individual coordinate values and so on. So you can choose to move those up or down. You can choose which tests you do, and we are sort of grouping those together. So if you just want to do an OGC test, you can choose whether you're going to do those, or you can choose to do basic geometry, integrity, and so on. And I think down the road what we're looking to do is actually looking for custom clusters of tests that might pertain to a specific database. So down here in a set of issues to detect, you might have for Oracle or for Esri geodatabase and so on. And we would choose which specific tests Esri cares about, and perhaps which specific parameters on those individual tests we need to set to make sure that the geometry that you're working with is valid for Esri data sets. And within that geometry validator, we've also added tests for some of the 3D geometries that we're working with. So in this example here, there's a bit of a building here that's got some inverted faces as an example. And once you've run it through the repair, it'll fix up those faces and that building will appear here correctly. So we are doing more and more around the testing of 3D geometries as well as conventional 2D and 2.5D geometries. Okay. Any questions on that quick enlightening, I hope, lightning talk? All right, so Dale is going to give us a presentation on
I don't even know.
map text labeler and LiDAR, perhaps?
Let's do that.
Okay.
All right. So what we're going to do is a particular example that one customer had. Mark, did this come into you, actually? This was your thing? So working with LiDAR data. So basically, we can do all these other things with point clouds, but this was an interesting application of actually starting to move up the value chain and add some other kinds of analysis or extract some value out. So you can see here the whole the whole workflow, but basically we've got 9 gig of input files. We want to basically determine or highlight areas where Mark should actually be the guy doing this. I'm going to be looking at you to see if I'm right or not, but I think we're trying to find out the places where the trees or vegetation has grown above some thresholds. So we're going to basically go and chop the whole point cloud up into all little pieces. Within each piece, figure out what the vegetation height is in that piece, and then color those cells ultimately afterwards. And so if I go here and look, with any luck at all, I have the workspace here. And I ran this earlier because it does take about 4 minutes to grind this whole thing. But here's where the magic happens. We take the data, first of all, and tile it into 10 by 10 pieces. Then we go and we run it through a point cloud classifier. And is this thing on the FME store, Mark, or is it your own? It is, yeah. So basically this will filter the point cloud according to the LAS standard classification codes. And so basically I'm chucking out everything other than classification code 2, which is the ground, and 5, which is the highest vegetation. So I've thrown away everything else. And now once I've done that, I basically have itty-bitty little point clouds, one for every tile, that have in them the ground and the highest. And so now all we do is grab the bounds in X and Y. That gives me the kind of rectangle on the ground. And then secondly, we grab the bounds to get the Z high and Z min and Z max. And so with that, I've got the cube basically. And now here I get the delta, which is the Z diff, which is the max minus the min. And then we throw it out here. And so this is the output of the whole thing. In the back is the point cloud, so we can start to flip some stuff off and on. There's the original point cloud, and here is our canopy that we calculated. And if I zoom in somewhere here like this, oh, it may take a second. I may regret having done that. Anyway, now it's got basically, my problem is that I'm looking at the point cloud, and the data inspector is grabbing that. But if I click on there, in a minute, these purple ones, I believe, are the highest, right, Mark? And you'll be able to see that. Yeah, I do regret doing that. So it's got a basic, oh, there we go. Okay, so here we go, and you see that the diff is 27 meters, and that was enough to be highlighted. So that's an interesting example. In very few, it would meet the Don Murray test pretty much, this workspace. Not many more than 10 transformers to wring some good value out of a LiDAR scan, and then highlight areas where we may want to go and look at the trees and, I guess, chop them down. What could be more green than that? So let's go on to our last thing before we have our exciting quiz to end the day. And Mark, you're the quiz master, I guess? Yeah. Okay. Because I've never done it on my computer, and I know there's very good sound effects that go with this. Actually, Don, did you say the East Coast team didn't know about the sound effects till quite late in the tour? Yeah. So it's always, there's hidden Easter eggs whenever you're on tour with the FME World Tour group. Okay, so just a few things about the map text labeler. This is something that customers have asked us about for probably 10 or 15 years. Some customers went ahead and worked with map text, which is another company that specializes in placing labels, and made their own plugin for FME to communicate with this. So the Danish mapping agency, as well as a group in Western Australia, Northern Territories, let me get it right, Darwin, I think we say. I think that they did this as well. But finally, SAFE and MapText worked together to inject this technology into FME. Now, it is extra cost, so I feel a little bit bad that this would be something you have to buy, but it is, for the right people, it is incredible value. It's worth being aware of. Plus, I'm going to show you some things that you may not have known about FME that are valuable to know on their own, but it's interesting when you combine FME with MapText with things you can do. So anyway, they've been doing this forever. They've studied all these font descenders, know that some of the things Jonathan was fighting with. That's what these guys do. And anyway, it's great to have them in with FME. So simple area labeling. So let's just do 0. This is all Vancouver stuff, so it's nice to be home here to kind of show it. And the thing about this, because it is a skill testing question, I do need to show, if you say map text labeler and put one down, you have precisely 0 inputs and outputs. So this is a little bit of a usability problem, and we will try to make this more obvious. But what you have to do is go in here first and define the layers. It's because you can have many different things feeding into here at once to be labeled all in one shot. So there's no actual physical limit. So I'm just going to go and import something in here. I have to pick my output format. And Jonathan, I'm pleased to tell you that actually it turns out that ArcGIS and PDF were separated at birth as far as their font genetics go. So if you choose ArcGIS and you go to PDF, it seems to be the same font metrics, and they work really well. So well that I think we're going to add PDF to our pull-down list here and just use ArcGIS underneath and not tell you. So anyway, that's what we do there. You've got to also say how many ground units per font point. And that's because label people think in terms of font points. I think in terms of ground units. And I was one of the authors of FME, and so darn it, FME works in ground units. So we have this bit of a mismatch. We've got to do a conversion somewhere. So if I say 10 ground units per font point, when I go into map text and say 6 font points, that's going to be roughly 60 meters when I'm out on the other side. So that's kind of a funny thing that you have to do, but you do have to do it. And Dimitri, I'm sure, would love to talk to you about whether we should support map scale or not. Having done that, I can now hit configure, and here's where I would go and first of all say to map text, okay, that's going to be an area-based thing. Please label it. And then, whoops, I guess I have to find the style first. And so I can go and say, yep, label the name, please. And make a rule. Let's place it by the extending at the dominant angle, sure, and say create. And now I should be able to hit this. And then I could say OK and OK. And now I have something coming in and something coming out. And so that's how you set this thing up. So in this example, I'm just going to fire it up. I've set it to run to our viewer. And it pops up. And I will have labeled all of the neighborhoods of Vancouver by their dominant angle. If I say, you know, gee, I don't like that, let's go in here, let's configure this thing, let's adjust the rule and say, let's make it tight against the boundary instead. Say OK, OK, and OK. Then we run this, you'll see that it's all tight now. And so this is part of the flexibility here. Yeah, you can see, there we go. We are tight in against the boundary. So because I can define different rules for each input port, and because I have no limit on the number of input ports, I can start to do some fun things. I could, for example, divide my neighborhoods up into the small ones and large ones, have 2 input ports, and label the small ones differently than I label the large ones, using different rules. I'm limited by my imagination here. So that's a simple. Again, to recap, we add all of our layers. In there, you also get to define priority, because this is one thing I didn't know. The labeler does not promise to label everything. And so it may not be able to fit things in, so then you can indicate which things are more important than others. And then Dimitri has done some tricks in FME afterwards to figure out who didn't get a label, and maybe we can give them a second crack using different parameters, and we'll show that in a minute. So again, we set the geometry types and priorities. The styles, you'd have these rules, and these are for points. There's different rules for areas, and again, different rules for lines. So you've got a full engine in there. And now here's all the output formats as well. So that's one of the unique things here, because yes, ArcGIS and GeoMedia and a bunch of these tools already can produce labels, but you know what? They can't produce labels if you're going to try to target AutoCAD, or you're going to want to go to MicroStation or some of these other formats. So that's where you can do some of the power, is to be able to target precisely the system that you want and to get some sophisticated outputs. I'll mention as well, and Jonathan I think was talking about this in his thing as well, we can also always go to the famous FME text stroker, which I'm not sure how widely known it is. If I go to use FME generic and go to the text stroker, now I'm going to get polygons out that are the text. So in Denver, one person said that by doing this, I'll have completed the circle. We'll have started with CAD data that was dumb and without attribution, didn't know what it was, run it through FME, created smarts, done some smart things, run it through a labeler, built something beautiful, and then created dumb CAD data again afterwards that no longer knows what it was. So yes, you can do this, but it would work then no matter where you output it, but it wouldn't know what it was originally. But where this is particularly interesting is if you're rasterizing. If you were using FME to do web map tiling or something, you could label with map text, then stroke, then rasterize with FME, and now you've got beautiful labels in your raster. Okay, so that's that one. Right, so let's go label the transit system of Vancouver, just for fun. So we'll do this. No, I won't save that. Transit labeling is number 1, and we'll go ahead and run this. And in this case, I'm actually outputting to microstation design just to prove that we actually can use something else. And that was the thing popping up in the FME viewer. Oh, I didn't output. I was set to do this. So let me do this and run her again. We'll go to design files this time. And I'll also show one of the great things in FME. Thank you, Jason Birch. Yeah, that's the input. I can say open containing folder. What we learned was that about half the time that people spend using FME is hunting for their output. And so we've made this easier for you. And there's a Vancouver Live, which I just produced. And let me grab this guy, and it should see Vancouver Live. And so this is the free Bentley viewer, which with any luck will open up that small file. Okay. And it's, there's probably 300 or 400 features in there that need to be rendered. Sorry, Bentley friends, but it will take a minute while it swaps in. And then we'll have the fun of panning and zooming around in here. So anyway, here they all are in their glory. And you can see them nicely. Let's get rid of this. And now we can do this. Now what I've found, and I know that there's a police officer in here, but really I don't think you should use this with a blood alcohol level of more than 0.05, because this is kind of a wild zooming tool. And whoa, okay. So anyway, you get the sense of this thing. And yes, we got nice labels of the whole thing. I should ask Dimitri if there's any part in particular. The expo line nicely expoed out here, and so on. So anyway, that's that one. And so that's transit system labeling. Now we start to do some more interesting FME mixtures in here. What if we have something big we want to label, like Mother Russia or Australia? We can start to pad them out by injecting spaces in between the words or the letters. And here, British Columbia, let's inject a carriage return or a couple of new lines. If we know we've got a long thing that's kind of narrow, we can do that. Or better yet, the Philippines. I like picking on the Philippines, and so let's go and pick on the Philippines. This shows off something that we have to thank our friends at NRCan for. Some years ago, NRCan came to us and said, we are working to generalize maps of Canada. Turns out most of Canada is really little tiny bits of island in the north, and when you got them at a very low level of detail, high level of detail. I always get mixed up on this. High level of detail. There's lots and lots of little islands. If we want to kind of zoom out a bit, well, all those little blobs are now too small, but what we might want to do is kind of artistically group them together. In amalgamation is the thing. So FME has this amalgamator transformer whose job it is to take little bitty pieces and make something that is kind of like that shape but bigger. So let's just go ahead and amalgamate our friends the Philippines and look at what happens here. A great and interesting tool. So let's, don't look. Okay, so here's the original Philippines. And if we just label them naively, we get this. And I have Dimitri here. Dimitri, as a cartographer, how do you like these labels? He doesn't like them. And he shouldn't. They're not good. So let's get rid of them. And let's say, instead of the original Philippines, what if we amalgamated the Philippines into that? So temporarily make a fake geometry. We will never actually store this geometry. We make this temporarily in our workspace, and then we lie to map text and say, here's the Philippines, please label. And so then the Philippines comes out like that, which looks pleasant. And then inside of our FME workflow, we just throw away the Philippines amalgamated and go back to the original, and you know what? It looks good. And so this is, again, combining the power of FME with the map text labeler. We make something that isn't real, label the unreal thing, throw away the unreal thing, and we've got a nice label. And so That's amalgamation. So while I begin to talk about the next thing, we're going to go for complete and total world domination here. World labeling domination. So I'm going to let this run while I go out here. So that's amalgamation. Right, we did that. So now you can start to add some other FME power into things. Look at the size of things. Look at the area. Look at the length. Figure out, are these things fairly circular? There's a circularity thing in FME. Or are they skinny and narrow? Which way are they tilted? You can start to filter all these things and then route to different labeling rules within one labeling workflow. And that's this world domination thing. And so while I'm letting that run, we'll also talk, we can label North America. And the Saskabush guys, look at how nice that is. They get their labels going up and down, and everybody else gets theirs square, but New Brunswick gets at an angle. All of this is done by routing things to different rules. And the Americans get all their labels as well. So you can zoom in here. Most of the states are all big enough to have their labels horizontally, so then we don't have a problem. So let's go back here. I think we're still busy labeling the world, but I'll talk about a couple things here. So this area here is where the guys who were aggregates or multi-part are getting amalgamated. And then ultimately, we route all the countries through this test filter, which basically divides people up by their area. So we got big countries, average and small, and the technically named teeny countries down here. So the big guys go into a space adder, which is going to pad out their names with extra spaces. The average guys and the small guys go into here. These guys all get labeled at once with different rules for everyone. And the output of these is taken down to a feature merger to figure out who didn't get labeled. And the guys who didn't get labeled, together with the teeny guys, go into this flow here, which gives each country a number. And then we're going to try another crack at the labeler, where these guys that didn't get a label the first time get instead labeled up here with their number. And what we also do is replace all the other labels we did make with their bounding boxes. Whoops, don't look. With their bounding boxes, so that we don't put any of the numbers colliding with the labels we already made. So if I look in here, I can see that this says the tiny guys, and they're going to be labeled, and the areas are not. These areas are the bounding boxes of the existing labels. And so I think that's probably the magic of this thing. And so when we get to see the world here, we see here's the list of all the guys who didn't get labeled. We look at guys like Canada. Canada would have been amalgamated and labeled, which is why we're crossing over into Hudson's Bay here. If I go down, see Mexico also would have gotten amalgamated. If I look over here it's always dangerous to kind of look in here, but let's take a look in the middle. Let's not look in the Middle East, but let's take a look over here and see that the Croatians managed to get a label. They would have been amalgamated, and they were big enough to get a label, but sorry, Serbs and Macedonians or Slovenians maybe. These guys didn't, they got just numbers. And if we go over to Southeast Asia, let's take a look what happened down here. Indonesia, a great example of amalgamation working, and the Philippines as well, but Papua New Guinea, no problem for it. And then lastly, we take a look over here at the legend. This is all the guys who got numbers, and we see, whoops, we see that Tuvalu gets number 1, as it should. Okay, and so we'll leave it there. And right, we saw this morning the kind of fancy pants stuff we can do as well by injecting colors and things afterwards into a multi-line label to highlight certain things, so we won't discuss that further today, right now. Lastly, Dimitri's done some experimentation where you engage FME's parallel processing on the labeler if you know you have chunks of labels that don't interact. So in my previous example, I probably could get away going by continent and do the world in a bunch of different processes where I do North America, South America, Europe. Europe and Asia maybe I'd lump into one, but I probably am okay. Africa and Australia, all of them separately, then it would get done quicker. And Dimitri's done some examples with labeling utility things in subdivisions and forking them out based on subdivision or region and getting it done basically 8 times faster. So if you're interested in the parallel processing, you can look at that there. So if you have any questions today, Dimitri is with us. Go ahead and ask him. Otherwise, visit safe.com/maptext. where you'll see a number of a bit of marketing fluff, a nicely made video by Tiana as well that kind of goes through these same things, but more importantly of all, a link to FMEpedia, which gets into the details of how you actually configure this thing if you really want to do a great job of microstation. That's the trickiest one. The other ones are not as tricky, but Jonathan, PDF would do well, and some of your workflows you might be able to make use of this as well. So anyway, that is it for me. And so, Mark, I think you're going to wrap us up.
We're going to try and wrap up for the day.
Do we need some other spotters up here?
We need some spotters and prize giveaways. So this is where you earn your price of entry, actually. So we got
Fistful of sporks that I'm not afraid to use.
sporks, water bottles to give away,
Okay.
T-shirts.
T-shirts. We just sort the T-shirts by size. Woo, my voice is going. Okay, hats galore.
Hats galore.
Uh-oh. We got a significant number of stickers.
Significant number of stickers. Now, these stickers are more valuable than they appear because they do convert your Dell workstation into a higher-end Apple-like device if you stick it on that. So they are worth opting for. So what we're going to do is we've got 16 questions, random questions today that I think are going through.
Mark, we're going to give away these chocolate bars too.
Oh, yeah. So these
can't
are
have them.
in the theme of the day, consolation prizes, Mars and Milky Ways for...
Okay.
Who's going to get those away?
So we need spotters ready to go.
I've got a blank screen. Oh, yeah. So were you paying attention today? This is your chance to prove that you were, I think.
You know what size? Okay, it's XL.
And so one of our expensive movie costs. If we got some sound on the sounding devices. Are you ready? We need people over there giving away prizes. Okay. 16 questions to get us through to the end of the day. So let's start out simply. What's the splash screen for 2013? So we want good behavior from the crowd. Hands up, first person to get picked will get a prize, and so on. Zipster is the right answer. So we need a bit of sound there at that end there. Okay. Okay, so that was an easy start to the day. We've got a lot more prizes to go, so we need to be a bit more generous with the prizes. So we're not taking anything home, so we need more hands up. Okay, which gives you better performance, a Tesla S or FME 2013? FME by far. Any others? Any other guesses there? I'll give you a clue. Any other guesses? I'll give you another clue. Any other guesses for a T-shirt?
There's one over there.
Who said all for all of the above? Yes, FME better than a Tesla by far. It's not a very exploratory and risk-taking crowd today. Okay, working with networks, which one of these transformers could help to align to mile markers? So these are about presentations that we didn't give today. So, you need to have been following the Twitter feeds for the World Tour last week, and you might be able to...
Or just put up your hand.
Oh, it just...
Could be good enough.
Yes, that could be good enough. Any hands going up? Making...
Hey, here's a hand here. Right there.
What did you say? Shortest path? Fine. Oh, sorry about that one. Ted. Path builder. Sorry, consolation prize is going out here. Neighbor finder. Who is the neighbor finder persons? Yeah. Okay, yes. Grabbing features that are side by side is good neighbor behavior. FME servers coming to the cloud. How fast can we launch an instance for you? Okay, people are shouting out. Instead of putting their hands up, we need a little bit more control from Don Murray. Who's got 9 minutes? Somebody over here. Lots of stickers going out. I got piles of stickers. Yeah. For consolation prizes. Okay. I'm not counting the number of questions. We had 16, so we're about 4 or 5 in. Okay, our friends from Spain, what were they classifying with their raster data? Hands? Okay, agricultural and vegetation cover. Somebody was listening throughout the day. That's encouraging. Okay, so in Seattle, Socrata gave a presentation and talked about their API. So what was their API called? Anybody who's a Socrata user here? Yes? Soda, that is correct. It's not the REST API. It's a Soda Pop API.
There's also a pattern to the answer.
Could be. There could be patterns involved here. Geometry validation transformer is capable of making how many tests on your spatial data? Yep. 12, yes. Somebody was listening and still awake this afternoon. Good coffee at the lunch break. On the road presentation, what new Workbench capability was used to set a transformer parameter value based on the result of a test? Yes, set conditional value. Really useful transformer capability that, and in some cases it could reduce your workspace complexity quite significantly. So give that a go in your new workspaces. On the road presentation, what transformer was used to snap the Tesla report points to the Vancouver road network? Yes, yes, a prize from our guest from Dallas. Maybe a hat. No more hats. No. Bad luck. Okay. Okay, Kansas DOD built an online tool for property developers to evaluate the effects of their construction on what? Airspace. We had a couple there. We got prizes. You run out prizes there, stickers. Is that all we got left there? We're almost out. Way too generous in the prize giving. On the road demo showed FME reading customer data accounts from which cloud database? Okay, there's some stickers going over there. Yep, we're working with Salesforce, but of course we do support Azure, Fusion Tables, and OData, none of which we demoed today. In our on-the-track presentation, we were looking at traffic analysis and what was the problem we were looking at. There, back there, we got some black spots, all related to Treasure Island. When you got the black spot, the time was up. And in Calgary, Sophie Duan presentation showed how FME was being used to create an Excel spreadsheet for recording what? Any guesses? Oh, sorry about that. There was nobody there. Don gets a sticker and a zipster. And in Ottawa, Eric Story's presentation showed a winter project where FME helped handle a GPS tracking data. What was it? Salt distribution. Yeah, somebody's catching on to the pattern. Who was that? Anybody want a sticker? Come on, we can whiz these things out to different people. And in Seattle, Jubal Harster was using a custom transformer in his workflow. Where did he get the transformer from? FME store. Nobody's putting their hands up. And finally, we've got one more prize left.
Got a giant shirt.
A giant shirt. For a giant shirt. In today's presentation, the PDF was the primary output. Which FME service did they deliver the PDF to the users through? For a giant shirt. And it looks like Ashley's got a whole bunch of stuff up here. There we go. We're Or if you have a teenage daughter, they can use it as a nightshirt or something. That's what my daughter would use. Well, that's it. So thanks a lot for participating in that. I think that just about wraps up our day. So please fill out your feedback forms. They're back on the back of your agendas there. It does really give us a lot of use. I want to give a special thanks to Steve for flying up from Dallas to give this presentation here.
Yeah, thank you. And we also need to thank Ashley for all the fabulous work, not just here today organizing everything for us, and Celia as well, but also for the last, 16 of these or something. This is the 17th one we did in about 10 days. So thank you two so much, and Roger and the marketing group for all the work you did as well. So thank you.
And for the entire team that managed to risk traveling on the road with Dale and myself.
And Mark.
We really appreciate that.
Yes, and all the people at SAFE that work behind the scenes, Dimitri and others, and so many more of Mark's team that put together all these presentations. Really appreciate that. The World Tour is going to continue now in Europe and Australia and other places, New Zealand, South America, and so on. There'll be a total of 48 stops. We're done ours, how many? 49? So we're done our 17. It'll wrap up in Berlin. Don and I get to go there in June. But for today, I just want to thank all of you so much for coming out. We really appreciate the support of our home crowd here. You've been great customers for us since the beginning of time, really. And we appreciate so much that you come and spend your day with us. We love the chance to interact with you, to learn from you. And so just thank you for that.
And at SAFE, we talk about the restaurant model. We've talked a lot about our product today, but don't forget the service. I was having lunch with some folks, and they said, well, FME, there's so many transformers. How do I get started? And really rely on our support. Support you don't contact just if it doesn't install or you find a bug. As you're starting to use FME, as you're ramping up, that's what support from SAFE and our partners worldwide is all about. So engage with us, and we can just push you up that learning curve, very, very quickly. It is a complex, powerful product, and it's not something you're going to open. We all hate to, and just use. We all hate to see that blank screen, and it doesn't matter what you're doing. If you get a sample that gets you part way, it just can be hugely helpful. So please test out the restaurant model. It's quite unique for a software company because we know that to go to a restaurant, you have to get product and service, and we believe the same thing at SAFE as do all our partners.
Yes. So anyway, thank you all so much. Enjoy.